Look up at the night sky. For a moment, forget the familiar pinpricks of light, the constellations we've named for millennia. Instead, I want you to consider the profound emptiness between them, that vast, silent ocean we call space. It feels distant, almost abstract, but what if I told you that right now, as you watch this, that immense void is not empty at all? It is a floating museum, a chaotic junkyard, a gallery of the utterly bizarre, filled with objects so strange they defy our wildest imaginations. We picture space as a place of pristine planets and orderly stars, but the reality is far more peculiar. Drifting in the endless dark are relics of human ambition, freaks of cosmic nature, and artifacts of pure mystery, each with a story that challenges everything we think we know about our place in the universe. This is not just about the majestic planets or the swirling galaxies we see in documentaries. We are about to journey into the cosmic shadows, to explore the forgotten, the anomalous, and the downright weird. We will encounter human-made artifacts sleeping in eternal orbits, from a single glove lost by an astronaut to entire, silent space stations holding the echoes of past voyages. We will investigate natural phenomena that seem to break the laws of physics, oddballs that have left scientists scratching their heads for decades. This is the untold story of our cosmic backyard, a collection of 30 of the most peculiar things floating in space at this very second. Some are hilarious accidents of history, while others are profound enigmas that whisper of secrets we have yet to uncover. So prepare to have your perspective shifted. We're going to look beyond the star charts and dive into a reality that is stranger, funnier, and more astonishing than any science fiction. This is a tour of the cosmic curiosities that share our solar system, a celebration of the odd, the unexpected, and the wonderfully weird. From the first satellite we ever launched to the interstellar visitor that came from another star, each entry on our list is a testament to the sheer unpredictability of the cosmos and the curious nature of humanity itself. The journey starts now, just beyond the edge of our atmosphere, in the silent, crowded, and endlessly fascinating darkness of space. Our tour of the cosmic strange begins not with a human-made object, but with a natural masterpiece of celestial horror. Hovering about 900 light-years from Earth, in the constellation of Orion, is a phantom known as the Witch Head Nebula. Its official designation is a sterile string of letters and numbers, ISEE 2118, but its appearance is anything but clinical. Imagine a spectral face emerging from the depths of space, with a long, hooked nose and a gaunt, flowing profile, like a witch frozen mid-cackle against the backdrop of eternity. This is not a trick of the light or an artist's interpretation. It is a real structure, a vast cloud of gas and dust, sculpted into one of the most recognizable and unsettling shapes in the heavens. The eerie glow of this cosmic witch is not its own. It is a ghost lit by a brilliant lantern. The nebula is situated relatively close to Rigel, the brilliant blue supergiant that marks Orion's left foot. Rigel is a stellar behemoth, burning with an intensity tens of thousands of times greater than our own sun. Its powerful radiation acts like a cosmic spotlight, illuminating the witch head from behind. But the star's influence is more than just passive lighting. The relentless stellar winds and immense radiation pressure flowing from Rigel are actively carving the nebula. They push and erode the delicate tendrils of gas and dust, much like ocean waves sculpt a shoreline of sand. This ongoing process means the witch's face is not a permanent statue. It is a dynamic and evolving entity, slowly changing its form over immense timescales. What we are witnessing is a fleeting moment in a cosmic drama. The same forces that give the nebula its haunting glow are also contributing to its eventual dispersal. The delicate filaments that define its witch-like silhouette are being steadily dissipated by the very star that makes them visible. This creates a beautiful and profound paradox, a celestial object defined by its own destruction. It serves as a stunning reminder that the universe is not a static museum display, but a vibrant, violent, and ever-changing arena. The Witch Head Nebula is our first piece of evidence that the weirdness of space is not just about odd shapes, but about the incredible forces and fleeting moments that create them. Leaving behind the ghostly visage of the Witch Head Nebula, we now turn our attention to an object that is profoundly, undeniably human in its origin, yet just as surreal in its context. Drifting along a wide elliptical path around the sun is a sight that would make any astronomer do a double take: a cherry red Tesla Roadster. This is not a computer rendering or a conceptual artist's dream. It is a real automobile, launched into space in February 2018, atop SpaceX's inaugural Falcon Heavy rocket. The car serves as a brilliant, almost whimsical counterpoint to the solemn, scientific payloads we typically send into the cosmos. It is a consumer product, a symbol of earthly luxury and speed, which has been permanently promoted to the status of an interplanetary artifact. The car's sole occupant is a mannequin dressed in a full spacesuit, christened Starman by SpaceX founder Elon Musk. Starman sits calmly at the wheel, his right hand resting casually on it, as if he's on a leisurely Sunday drive through the solar system. On the car's dashboard display, a message flashes with a knowing wink to science fiction fans. Don't panic. This phrase, borrowed directly from Douglas Adams' classic novel, The Hitchhiker's Guide to the Galaxy, perfectly encapsulates the spirit of the entire endeavor. It is a gesture of humor and humility, acknowledging the sheer absurdity of the situation, while also paying homage to a story about the wonders and perils of space exploration. It transforms the Roadster from mere space junk into a cultural time capsule, a piece of performance art on a cosmic stage. This automotive oddity is not simply drifting aimlessly. It is in a stable orbit around the sun, a journey that takes about 557 days to complete. This path periodically brings the Roadster relatively close to Mars, and its trajectory has been calculated to extend far into the future. For now, it is a silent testament to human ambition and our capacity for playful experimentation, but its long-term fate is a subject of celestial speculation. Orbital dynamicists have projected its path over millions of years, and their models suggest a dramatic conclusion. The subtle gravitational tugs from planets, primarily Earth and Venus, will slowly perturb the car's orbit over eons. Eventually, the most likely outcome is a fiery demise, with the Tesla Roadster crashing into either Venus or Earth itself. Imagine, millions of years from now, our distant descendants, or perhaps an alien species, witnessing the re-entry of this perfectly preserved relic from a long-vanished civilization. What makes the Tesla Roadster so compellingly weird is its sheer incongruity. In the sterile, vacuum-hardened environment of space, surrounded by asteroids and planets shaped by billions of years of natural forces, there is a glossy red car with functioning headlights that once illuminated California highways. It is a piece of our modern world, utterly divorced from its intended purpose and placed into a context where it becomes both meaningless and profoundly significant. It raises fascinating questions about what we value, what we choose to leave behind, and how our culture might be interpreted by anyone or anything that finds it in the distant future. It is a monument not to gods or kings, but to ingenuity, humor, and the audacious human spirit that looks at the infinite void and decides to send a convertible. Moving from a confirmed, if eccentric, human artifact like the Tesla Roadster, we venture now into the murkier waters of cosmic folklore with an object that has captured the imagination of conspiracy theorists for decades, the so-called Black Knight satellite. The legend tells of an ancient, alien probe of unknown origin, a dark, irregular shape silently orbiting our planet, its purpose and creators a complete mystery. Tales suggest it has been there for 13,000 years, perhaps observing human development, its existence covered up by world governments. It's a thrilling story, perfect for late-night radio shows and sci-fi thrillers. But the truth behind the Black Knight is a fascinating case study in how myths are born from the collision of imagination and misunderstood reality. The origins of this enduring myth are a patchwork of genuine historical events and creative misinterpretation. One key piece of the puzzle dates back to the late 1950s, when American newspapers reported that the U.S. Air Force had detected a mysterious, dark object in polar orbit. At the time, the space race was in its infancy, and fears of Soviet surveillance were high. It was later revealed that this object was likely the Discoverer program's secret Corona spy satellite, a classified project the Air Force could not acknowledge. The secrecy surrounding these early missions created a vacuum of information, which was quickly filled with speculation about extraterrestrial visitors. Another major contributor to the Black Knight's legend came from none other than Nikola Tesla. In 1899, while experimenting with his high-voltage radio transmitter in Colorado Springs, Tesla believed he had intercepted a repeating signal from space. He speculated it could be intelligent communication from Mars or another planet. Decades later, in the 1920s, amateur radio operators began picking up what they called long-delayed echoes, where their own signals would bounce back to them seconds after transmission, a phenomenon that was puzzling but later attributed to complex ionospheric effects. These early radio anomalies were retroactively folded into the Black Knight narrative, presented as evidence of an alien broadcast. The visual proof often cited is a grainy photograph from the 1998 Space Shuttle Endeavour mission. The image appears to show a dark, jagged object against the curvature of the Earth. However, this was definitively identified as a thermal blanket that had been lost during an earlier spacewalk. These blankets are essential for regulating a spacecraft's temperature, and losing one is a known, if unfortunate, occurrence. Drifting in the zero-gravity environment, the blanket took on an ominous, unnatural appearance, perfectly matching the human brain's tendency to see familiar patterns, a phenomenon known as pareidolia, in ambiguous shapes. This single piece of space debris became the iconic face of the alien satellite. In reality, what people have been calling the Black Knight for years is almost certainly a combination of many different, mundane objects. Earth's orbit is a crowded graveyard of defunct satellites, discarded rocket boosters, and other debris from over 6 decades of space activity. A piece of an old Soviet satellite, a stray insulation panel, or even a bag of tools lost by an astronaut can, from the right angle and under certain lighting conditions, look utterly inexplicable. There is no single Black Knight. Instead, the name has been applied to various pieces of space junk over the years, each sighting reinforcing the myth. So why does the story persist with such vigor, even in the face of rational explanations? It speaks to a fundamental human yearning. The idea of a silent, ancient watcher from the stars taps directly into our deepest desires and fears about the cosmos. It fulfills a longing for confirmation that we are not alone, that someone or something has taken an interest in our world. The mystery of early space exploration, a time when every new signal and every unidentified blip on a radar screen held the potential for monumental discovery, created a fertile ground for such legends. The Black Knight is more than just a misidentified piece of metal. It is a cultural artifact, a modern myth that reflects our own curiosity about the universe and our place within it. It is a weird thing not because of what it is, but because of what we have chosen to believe it represents. But after the grounded, albeit peculiar, stories of the Witch Head Nebula, the Tesla, and the myth of the Black Knight, our journey takes a sharp turn toward a mystery that is both real and profoundly unsettling. In October 2017, astronomers at the University of Hawaii's Pan-STARRS 1 telescope spotted something that should not have been there. Drifting at high speed against the backdrop of stars was a faint point of light, and its trajectory was unequivocal. It was not orbiting the sun. It was falling into our solar system from above the plane of the planets, swinging around our star, and then hurtling back out into the deep void, never to return. This was not a local asteroid or a comet from our own celestial neighborhood. This was a visitor. It was given a name that captured its essence perfectly: Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. What made Oumuamua instantly bizarre was its shape. Based on the dramatic way its brightness fluctuated as it tumbled end over end, scientists deduced it was highly elongated, perhaps 10 times as long as it was wide. The most common comparison was a cigar, a dark, reddish object tumbling through space like a log tossed in a cosmic river. This was unusual in itself, as most asteroids and comets we observe are far more lumpy and spherical. But the real shock came weeks later, as astronomers continued to track its path after its closest approach to the sun. They made a startling discovery: Oumuamua was accelerating. It was not simply following a predictable gravitational arc. Something was giving it an extra push. For a standard comet, this is easily explained. As a comet nears the sun, its ice heats up and turns to gas, erupting from the surface in jets that act like tiny rocket engines, a process called outgassing. This creates the beautiful, fuzzy coma and tail we associate with comets. But Oumuamua had no coma, no tail, no visible outgassing whatsoever. It was, to all appearances, a barren, rocky asteroid, yet it was behaving like a comet. This paradox is where the mystery truly deepened and where speculation, including the extraordinary, took flight. The absence of visible outgassing combined with the unexplained acceleration led some scientists, most notably Harvard astronomer Avi Loeb, to propose a radical hypothesis. Could Oumuamua be an artificial object, perhaps a light sail, a piece of alien technology that uses the pressure of starlight for propulsion, much like a sailboat uses the wind? In this scenario, the acceleration wasn't from gas jets, but from the gentle, constant push of solar radiation pressure on a vast, thin, reflective sheet. The object's unusual shape could be ideal for an interstellar probe designed to sail between stars. This idea, while sensational, was a serious attempt to account for the observed data that defied conventional explanation. It forced the scientific community and the public alike to confront a thrilling, if disquieting, possibility that we had just witnessed our first piece of interstellar debris, and it might not be a natural rock at all. Of course, the scientific process demands that natural explanations be exhausted before we leap to extraterrestrial ones. Researchers have since proposed several compelling theories that do not require alien engineers. The leading idea suggests that Oumuamua was indeed a comet, but a very exotic one. After its long journey through interstellar space, bombarded by cosmic radiation, its outer layers may have become baked into a thick, carbon-rich crust. When it passed close to our sun, the heat could have triggered the release of hydrogen gas trapped deep within its icy body. Because hydrogen is invisible to our telescopes, this outgassing would have provided the necessary thrust without creating a visible coma. Think of it like a block of dry ice sublimating away. You can't see the carbon dioxide gas, but you can see its effect. Another theory posits that the acceleration could have been caused by the ejection of large, dusty particles that were too sparse to reflect much light, or even that the object was a porous, fluffy aggregate of material, a cosmic dust bunny, whose very low density made it exceptionally responsive to non-gravitational forces. What remains undeniable is Oumuamua's historic significance. It is the first confirmed interstellar object ever detected in our solar system, proving that the exchange of material between star systems is a real phenomenon. Its brief, enigmatic passage has permanently altered our understanding of the cosmos. We now know that our solar system is not an isolated island. It is a port visited by strange drifters from the galactic ocean. The fact that it was so weird, so defiant of easy categorization, only makes its legacy more profound. It serves as a humbling reminder of how much we still have to learn. Oumuamua was a messenger, all right. It didn't bring a message in a language we could decipher, but its very existence delivered a powerful statement. The universe is full of surprises, and some of the strangest ones are just passing through. All the objects we've encountered so far have been relatively close, within our own cosmic backyard. But now, we must grapple with a force so immense it moves entire galaxies, a mystery that lies not just in space, but in the very direction our galaxy is headed. Imagine you're floating in a river, carried along by the current. You can feel the motion, but you can't see the waterfall ahead because a thick, impenetrable fog blocks your view. That is precisely our situation with the Great Attractor. We know our Milky Way galaxy, along with our local group of galaxies and thousands of others, are all streaming through the cosmos at an astonishing speed of over 600 kilometers per second. But the destination for this universal river, the source of this pull, is hidden from our sight, located in the constellation of Centaurus, behind the crowded, dusty core of our own galaxy. This region of obscurity is known to astronomers as the zone of avoidance. It's not a place of danger, but a simple consequence of our perspective. The disk of the Milky Way is filled with vast clouds of gas and dust that effectively act like a cosmic blindfold. Just as you can't see distant streetlights through a heavy fog, our optical telescopes cannot penetrate this dense band to see what lies beyond it in that particular direction. The Great Attractor, therefore, isn't just weird because of what it is, but because of where it is. It represents a fundamental blind spot in our map of the universe, a glaring question mark at the heart of our cosmic motion. For decades, we were essentially navigating by feeling the current without being able to see what was creating it. So, what could possibly exert such a powerful gravitational influence? The initial theories pointed to a massive, but otherwise normal, concentration of matter. Imagine a gravitational well so deep that it dominates an entire sector of space. Observations made with radio and X-ray telescopes, which can pierce through the interstellar dust, began to reveal a hint of the structure. They confirmed the presence of a vast supercluster of galaxies in that general area, now known as the Norma cluster. This concentration of mass is significant, but there's a problem. The math didn't quite add up. The gravitational pull we're experiencing seems to be far stronger than what this visible supercluster should be able to produce. It's like feeling a powerful tug on your leg, but when you look down, you only see a small child pulling at your shoelaces. The force is far greater than the visible source can explain. This discrepancy led scientists to propose an even grander explanation. Perhaps the Great Attractor is not the final destination, but merely a waypoint on a much longer journey. Our entire local universe, including the Great Attractor itself, may be flowing toward an even more colossal structure, lurking billions of light years beyond it. This ultimate source of the pull is known as the Shapley supercluster, the largest known concentration of galaxies in our observable universe. Think of it as the oceanic terminus for all the rivers in our cosmic neighborhood. The Great Attractor, in this scenario, is like a major whirlpool within that river, a significant concentration of mass that influences our immediate path, but the ultimate current is driven by the immense gravity of Shapley. This revelation fundamentally changed our understanding of the cosmos's large-scale structure. we no longer see galaxies as isolated islands, but as parts of an immense cosmic web, connected by filaments of dark matter and flowing along gravitational highways toward the densest nodes. The Great Attractor is one of these major nodes, a gravitational anchor in our corner of the universe. Its mystery persists because it forces us to confront the limits of our observation and the dominance of invisible forces. Most of the gravity at work here is not from the galaxies we can see, but from the enigmatic dark matter that clumps around them, creating a gravitational footprint far larger than the visible light would suggest. So, while we continue to map the hidden depths behind the zone of avoidance with more powerful instruments, the Great Attractor remains a profound symbol of our place in a dynamic, flowing universe, perpetually pulled toward a hidden, powerful, and deeply mysterious destination. Now, let's shift our focus from the grand, cosmic pull of the Great Attractor to a much smaller, but no less significant, artifact of human ingenuity that has been silently circling our planet for longer than most of us have been alive. High above the Earth, tracing an elliptical path that takes it from a few hundred to a few thousand kilometers high, is the Vanguard 1 satellite, launched by the United States on March 17, 1958. This unassuming little sphere holds a remarkable title. It is the oldest human-made object still in orbit around our planet. While its mission lasted only a few years, its journey has endured for over 6 decades, a tiny, metallic witness to the entire history of human spaceflight. To understand its significance, you have to picture the context. The late 1950s were the feverish opening chapter of the space race. The Soviet Union had stunned the world with the launch of Sputnik 1 just a few months earlier, and the United States was scrambling to respond. Vanguard 1 was America's answer, part of a project originally intended to be the first satellite. Though it wasn't the first, its successful launch and the longevity of its orbit were a massive scientific and propaganda victory. What's truly astonishing is its size. In an era where we imagine spacecraft as large as school buses, Vanguard 1 is almost impossibly modest. It's a polished aluminum sphere, barely 16 centimeters, or about 6 inches, in diameter, roughly the size of a grapefruit. It weighs just over 1.5 kilograms, a little more than 3 pounds. From its surface sprouted 6 small antennas, giving it the appearance of a strange, metallic sea urchin. Its scientific payload was simple by today's standards, but revolutionary for its time. It carried instruments to measure the density of the upper atmosphere and the effects of the space environment on its own systems. The data it sent back, powered by its mercury batteries and a handful of solar cells, a pioneering technology at the time, was crucial. It helped scientists understand the subtle drag of the very thin outer atmosphere on satellites, and confirmed that the Earth is slightly pear-shaped, bulging a little more in the southern hemisphere. But its most enduring legacy was not the date it collected, but the simple fact of its persistence. Its official transmission ceased in 1964 when its batteries finally died. Yet, Vanguard 1 did not fall back to Earth. Its high orbit, achieved by a much more powerful rocket than originally planned, placed it in a region where atmospheric drag is almost negligible. There, it has continued its silent vigil, a ghost from the dawn of the space age. This incredible durability is a double-edged sword. On one hand, it's a stunning tribute to the engineers who built it with such limited technology, creating an object so robust it has outlasted countless more advanced satellites. It is a monument to human ambition, a tiny, shining proof that we could reach for the stars and leave a permanent mark. But on the other hand, Vanguard 1 is also patient zero for a problem we are only now beginning to grapple with seriously: space debris. It was the very first piece of what has become a massive orbital junkyard. Today, it is joined by thousands of dead satellites, spent rocket stages, and millions of fragments from explosions and collisions, all whipping around the planet at tens of thousands of kilometers per hour. This cloud of debris poses a genuine threat to active satellites, the International Space Station, and future space missions, so Vanguard 1 stands as a powerful paradox. It is both a celebrated pioneer and the origin of a growing environmental crisis in low Earth orbit. It represents the triumph of reaching space and the unintended consequence of staying there indefinitely. Astronomers and space traffic controllers still track it meticulously, not for science, but for safety. Each time it passes overhead, it serves as a silent reminder of where we began and a sobering lesson about the long-term footprint of our technological progress. It is a tiny, historic marble that started it all, destined to circle our world for centuries to come, perhaps even outlasting the civilization that created it. While our journey so far has focused on physical objects and cosmic phenomena, our next entry ventures into a far more chilling realm of possibility, the eerie and enduring legend of the lost cosmonauts. This theory suggests a dark secret at the heart of the space race, that the Soviet Union launched other men and women into space before the officially recognized pioneers like Yuri Gagarin and Valentina Tereshkova. But these individuals perished in orbit, their deaths covered up by a state apparatus obsessed with propaganda and winning the Cold War. It is a story woven from static-filled radio intercepts, grainy photographs, and the testimony of those on the fringes, a ghost story whispered in the background of one of humanity's greatest achievements. The most famous source for these claims was a pair of Italian amateur radio operators, the Giudica Cordiglia brothers. In the early 1960s, they set up their own listening station and claimed to have recorded several disturbing transmissions in the days and weeks leading up to Gagarin's historic flight. One of the most haunting was a recording from May 1961, allegedly of a female cosmonaut. As her spacecraft apparently veered off course, her voice can be heard, with rising panic, reporting that she could see fire outside her capsule before the transmission cuts to silence. Other intercepts purportedly captured the agonizingly slow, labored breathing of a cosmonaut dying from oxygen starvation, their heartbeats fading away. These recordings, if authentic, would be undeniable proof of tragic, secret missions. Further fuel was added by alleged photographic evidence. Some grainy images surfaced that appeared to show Soviet spacecraft that had suffered catastrophic failures, along with reports from Western journalists who claimed to have seen classified documents or heard testimonies from insiders about these lost souls. The context of the time made these stories terrifyingly plausible. The Soviet space program was shrouded in immense secrecy. Missions were only announced after they were successfully completed. Failures were never publicly acknowledged. This culture of absolute control created a vacuum of information, and nature, especially human nature, abhors a vacuum. In the absence of facts, speculation and fear rushed in. However, when subjected to rigorous historical and scientific scrutiny, the evidence for the lost cosmonauts begins to unravel. Space agencies and historians point out significant flaws. The Giudica Cordiglia recordings, while dramatic, are impossible to verify independently. Critics argue the signals could have been clever hoaxes, misidentified transmissions from secret military aircraft, or even signals bounced off the moon. The timing and technical details often do not align with what we now know about early Soviet spacecraft capabilities. For instance, the technology for a female cosmonaut to fly a solo mission before Valentina Tereshkova in 1963 simply did not exist at the time of the alleged intercepts. The Soviet program was methodical and, despite its secrecy, left a detailed paper trail that has been extensively studied since the fall of the USSR. No evidence of these phantom flights has ever been found in the archives. So why does this legend persist with such power? It speaks profoundly to the atmosphere of the Cold War. The space race was not just a scientific competition. It was a high-stakes ideological battle for global supremacy. The pressure to achieve firsts was immense, and the potential for cutting corners or taking colossal risks was very real. The idea of a government sacrificing its own citizens for a propaganda victory is a terrifyingly human tragedy, one that resonates with our understanding of the period's political brutality. The lost cosmonauts are not just a conspiracy theory. They are a dark folktale, a narrative that gives a human face to the anonymous victims of that era's ambition and secrecy. They represent our collective anxiety about the hidden costs of progress and the lives that may have been silently lost in the race to conquer the final frontier. There are ghosts in the machine of history, a permanent, unsettling reminder of what might have been. Among the countless whispers of static that fill the cosmic radio spectrum, there is one signal that stands alone, a single, powerful shout that lasted for 72 seconds and then vanished without a trace. It is known forever by the name a stunned astronomer scrawled in the margin of a date, a printout, the WOW signal. The year was 1977, and the instrument was the Big Ear radio telescope at Ohio State University, a vast, stationary array designed to slowly scan the heavens as the Earth rotated. Its mission was part of the search for extraterrestrial intelligence, or SETI, a patient effort to find a needle of artificial transmission in a galactic haystack of natural noise. On August 15th, at 10:16 in the evening, it found something extraordinary. The signal was not a complex message or a sequence of numbers. It was a raw blast of power, but it had two very specific, very telling characteristics. First, it was a narrowband signal, concentrated around the frequency of 1420 megahertz. This is significant because this frequency is part of a protected, water-hole band, a quiet region of the radio spectrum where natural emissions from hydrogen and hydroxyl molecules are minimal. It's a logical place for an advanced civilization to broadcast a beacon, a clear channel shouting, "We are here." Second, the signal's intensity rose and fell in a perfect curve, exactly as you would expect if a distant, point-like source passed through the telescope's twin beams. It peaked and then faded away, a perfect match for the way the Big Ear scanned the sky. When volunteer researcher Jerry Amon reviewed the computer printout days later, he was astounded. Circling the alphanumeric sequence 6EQUJ5, which represented the signal's unprecedented strength, he wrote a single, emphatic word in red ink: "Wow." The signal was over 30 times stronger than the background noise, a spike so dramatic it seemed to defy any natural explanation. The immediate, electrifying question was, could this be it? After centuries of wondering, had we just received our first hello? The SETI community was abuzz with excitement and skepticism. The first order of business was to listen again. The Big Ear and other telescopes repeatedly pointed back toward the same patch of sky in the constellation Sagittarius, straining to hear a repeat of the mysterious broadcast. But the silence that followed was absolute. The WOW signal never returned. In the decades since, astronomers have pursued every conceivable natural explanation. One leading theory pointed the finger at a passing comet. In 2017, an astronomer noted that two comets, which had not been known in 1977, were in the vicinity at the time. The idea was that clouds of hydrogen gas surrounding these comets could have emitted a signal at the right frequency. However, this explanation was quickly dismantled. The comets were not actually in the beam of the telescope at the precise moment of the detection, and more critically, the specific frequency of the WOW signal would not have been generated by simple hydrogen clouds. Other proposals included a signal reflected off a piece of space debris, a brief burst from a military satellite, or an unusual stellar flare. Yet each of these fails to fully account for the signal's unique, narrowband profile and its perfect fit to the telescope's scan pattern, what makes the WOW signal so deeply compelling and persistently weird is its very perfection and its frustrating elusiveness. It was everything SETI researchers had hoped to find: strong, narrowband, and appearing in a logical frequency range. But its one-off nature makes it impossible to verify. It sits in a scientific limbo, too perfect to easily dismiss as noise, yet too singular to confirm as a genuine alien transmission. It is the ultimate cosmic tease, a single data point that hints at a universe teeming with possibility, but offers no proof. It serves as a powerful symbol of both the promise and the profound challenge of SETI. The universe is vast, and a 72-second broadcast from a distant star might simply be a fleeting event, a lighthouse beam that swept past Earth and may not swing our way again for thousands of years. The WOW signal remains a monument to human curiosity, a silent siren call from the depths of space that continues to challenge our place in the cosmos and our search for neighbors we may never truly hear from again. From the silent, speculative whispers of the WOW signal, we now travel to the surface of our neighboring planet, to a moment when a single photograph seemed to offer tangible proof that we were not alone in the solar system. In July of 1976, NASA's Viking 1 orbiter was methodically mapping the Martian landscape, searching for a suitable landing site for its companion lander. As it passed over a region called Cydonia Mensae, its camera snapped a picture of a particular mesa, a flat-topped hill common on Mars. When the image was transmitted back to Earth and processed, it caused an absolute sensation. There, staring up from the rust-colored sands of an alien world, was what appeared to be a colossal human face. It was over 3 kilometers from crown to chin, with seemingly symmetrical eyes, a distinct nose, and a mouth that seemed fixed in an enigmatic, almost stoic expression. It was an image that immediately captured the global imagination, igniting a firestorm of speculation that would burn for decades. This was not just a vague, cloud-like shape. To many, the face on Mars was unnervingly precise. It looked like a monumental sculpture, a sphinx of another world. In the climate of the 1970s, with the public still enthralled by Erich von Däniken's Chariots of the Gods and its theories of ancient astronauts, the face was seen as irrefutable evidence. Proponents argued it was a relic of a long-lost Martian civilization, a warning, a message, or a tombstone for a planet that had died. Perhaps it was built by the same beings who visited Earth and inspired our own pyramids. The idea was intoxicating. We were looking at the artwork of an intelligent species, a deliberate construction that confirmed the universe was populated. The low resolution of the Viking image was key to the mystery. The grainy, pixelated quality allowed the human mind to fill in the gaps, to see intricate details that may not have been there. It was a perfect canvas for projection. The scientific community, however, remained skeptical from the start. NASA scientists explained that the face was almost certainly a trick of light and shadow. The image had been taken when the sun was low on the Martian horizon, casting long, dramatic shadows across the mesa's surface. The symmetry was likely a coincidence of geology, and the human brain, they argued, was simply doing what it does best, finding familiar patterns in random shapes, a psychological phenomenon known as pareidolia. We see faces in clouds, in the moon, and in the burn marks on a piece of toast. It's a hardwired survival instinct to quickly identify potential threats or allies. But for believers, the official explanation felt like a cover-up, a dismissal of a profound discovery. The debate raged in books, documentaries, and late-night talk radio, creating a deep divide between mainstream science and passionate popular speculation. The controversy could only be settled with better data, and that finally arrived more than 20 years later. In April of 1998, the Mars Global Surveyor spacecraft equipped with a far superior camera, flew over the Cydonia region once again. The world waited with bated breath for the new images. When they were released, the result was, for many, anticlimactic. The face was gone. In its place was a clear, high-resolution picture of a perfectly natural, albeit interesting, geological feature. The new images, taken from a different angle and under different lighting conditions, showed an eroded mesa, a butte riddled with gullies and landslides. The symmetry was broken. It was clearly just a hill. What had appeared as distinct eyes were now revealed to be pits and shadows. The seemingly straight mouth line was a ridge of rock. The illusion, so powerful in the original photo, was completely shattered by the stark clarity of modern technology. This side-by-side comparison is a masterclass in how perspective can deceive us. The original Viking image was like viewing a mountain from an airplane window on a hazy day. Your brain assembles an impression based on limited information. The Mars Global Surveyor image was like being lowered onto the mountain by a helicopter with a high-definition camera. You could see the cracks, the boulders, the true, messy nature of the terrain. The face on Mars became one of the most famous and enduring examples of pareidolia in history. It wasn't a lie or a hoax. It was a genuine misinterpretation born from low-resolution data and the incredible power of human perception. The story of the face is not really about Mars. It's about us. It reveals our profound desire for connection, our hope that the cosmos is not a collection of dead rocks, but a place with a history as rich and complex as our own. The mesa in Cydonia is a natural wonder, a testament to the wind and erosion that shape worlds, but its legacy is as a cultural touchstone, a reminder that sometimes the weirdest things in space are not the objects themselves, but what we choose to see in them. Leaving behind the geological illusions of Mars and the tantalizing whispers of distant signals, we arrive at a mystery that was not about what we saw or heard, but about a subtle, persistent tug felt by two of our most intrepid robotic explorers. Launched in the early 1970s, Pioneer 10 and Pioneer 11 were true pathfinders. Pioneer 10 was the first spacecraft to travel through the asteroid belt and make a close flyby of Jupiter, while its twin, Pioneer 11, went on to become the first human-made object to visit Saturn. After completing their primary missions, they continued on trajectories that would eventually carry them out of the solar system entirely, becoming silent ambassadors on a one-way trip to the stars. For decades, as they journeyed into the profound cold and dark, teams of scientists on Earth carefully tracked their positions using the Deep Space Network. And that is when they noticed something deeply puzzling. The spacecraft were slowing down, not from the expected gravitational pull of the sun, which was gradually weakening with distance, but by an amount so small and yet so consistent that it defied all conventional explanation. This tiny, unaccounted for deceleration became known as the Pioneer Anomaly. It was an almost imperceptible drift, equivalent to a force 10 billion times weaker than the gravity we feel on Earth. To put that in perspective, it was like having an extra grain of sand's worth of weight gently holding the spacecraft back. This may sound insignificant, but in the precise world of orbital mechanics, where trajectories are calculated with extraordinary accuracy, even a discrepancy this small was a glaring red flag. It was as if the pioneers were driving with a ghostly foot on the brake pedal. For over 20 years, this anomaly haunted the physics community. It was a persistent data point that refused to go away, and it sparked a wave of extraordinary theories. Could this be the first measurable evidence of a flaw in Einstein's theory of general relativity? Perhaps gravity behaved slightly differently over immense interplanetary distances than our models predicted. Other, more exotic ideas suggested that the spacecraft were plowing through a halo of unseen dark matter clustered around our solar system, the drag from these invisible particles causing the slight slowdown. Some even speculated about the influence of higher dimensions or other new physics that would revolutionize our understanding of the cosmos. The Pioneer Anomaly represented a thrilling possibility that our most trusted robotic scouts were sending back data that could unlock a fundamental secret of the universe. The quest for an answer became a massive, long-term scientific detective story. A dedicated team led by Slavo Turishev spent years painstakingly recovering old data tapes, some stored in basements and attics, and analyzing decades of telemetry. They built incredibly detailed computer models of the Pioneer spacecraft, down to the last bolt and electrical wire. Their breakthrough came when they realized they needed to think not about external forces, but about the spacecraft themselves. The Pioneers were powered by radioisotope thermoelectric generators, which produced heat as a byproduct of generating electricity. This heat had to be radiated away into space to prevent the spacecraft from overheating. The team began to ask a critical question: was this heat radiating away perfectly evenly? The answer, it turned out, was no. The spacecraft were asymmetrical. Their electronics boxes, wiring, and especially the large main dish antenna acted like a complicated system of mirrors and radiators. The team's sophisticated thermal modeling revealed that slightly more heat was being emitted from the back of the spacecraft than from the front. This imbalance created a tiny but continuous thrust in the opposite direction, a thermal recoil force. Think of it like a very, very faint rocket engine. If you were to hold a warm light bulb in your hand in the vacuum of space, the photons of heat radiating from it would impart a minuscule push. Now imagine that bulb is warmer on one side. It would gently drift in the opposite direction. This is precisely what was happening to the Pioneers. The heat radiating from their warm bodies was giving them a constant, tiny push back toward the sun, which showed up in the data as an unexplained deceleration. The resolution of the Pioneer Anomaly is a powerful lesson in scientific humility and rigor. It was not a discovery of new physics, but a triumph of meticulous engineering analysis. The mystery was solved not by looking out into the cosmos for dark matter or rewritten laws, but by looking inward at the spacecraft we had built. It highlighted an effect that had been considered negligible, but over the vast distances and long durations of an interstellar journey, added up to a measurable discrepancy. This story underscores the importance of accounting for every variable, no matter how small. When we venture into the unknown, the Pioneers, in their silent voyage, taught us not about the secrets of the universe, but about the incredible precision required to understand our own creations as they slip into the eternal night. But after investigating the subtle, ghostly forces acting on the Pioneers, we now confront a far more tangible and immediate threat: a silent, spinning giant that haunts the orbital pathways just above our planet. This is the Envisat, the European Space Agency's environmental satellite, and it stands as a stark monument to both our technological ambition and our growing space debris problem. When it was launched in March 2002, it was the most complex and capable Earth observation satellite ever built, a sophisticated sentinel designed to monitor our planet's oceans, ice, land, and atmosphere. For a full decade, it beamed back a torrent of invaluable data, helping scientists track climate change, map deforestation, and monitor pollution. But in April 2012, without warning, it fell silent. Contact was abruptly lost, and Envisat, this 8-ton behemoth the size of a double-decker bus, became a ghost ship. What makes the Envisat so uniquely worrying is not just its size, but its behavior. It is not in a stable, controlled orbit. It is tumbling, spinning end over end in an unpredictable and chaotic fashion. This uncontrolled rotation transforms it from a dormant piece of hardware into a massively hazardous object. At its orbital altitude of about 780 kilometers, it travels at a staggering 28,000 kilometers per hour. At that speed, even a fleck of paint can crack the window of the International Space Station. The Envisat, with its vast solar arrays and sharp-edged instruments, is essentially a cannonball of shrapnel waiting to happen. A collision with even a small piece of debris would be catastrophic, creating a cloud of thousands of new fragments, each capable of destroying other satellites and triggering a chain reaction known as the Kessler syndrome, a scenario where low Earth orbit becomes so cluttered with debris that it becomes unusable for generations. The profound irony is impossible to ignore. This satellite, whose very purpose was to study and protect the Earth's environment, has itself become a major source of environmental pollution, albeit in a different realm. It is a classic case of unintended consequences, where a tool for good has been transformed into a persistent danger. Its orbit is particularly problematic. At that height, there is very little atmospheric drag to slowly pull it down to a fiery re-entry. Left to its own devices, Envisat could remain in orbit for over a century, a looming hazard for any new satellites we need to place in that crucial orbital band for climate science, communications, or national security. This has sparked serious discussions about the need for active debris removal, and Envisat is often the #1 target on any proposed cleanup list. But capturing and deorbiting a massive, tumbling object is a technological challenge of the highest order. You cannot simply grab it. A clumsy attempt could break off pieces or send it into an even more dangerous spin. Proposed missions involve concepts like shooting a harpoon into its structure to establish a firm connection, or using a robotic arm to gently grapple a specific, sturdy part of its frame. Once captured, a propulsion module would then need to fire its engines to lower the satellite's orbit, guiding it on a controlled plunge into a remote area of the Pacific Ocean. Such a mission would be incredibly complex and expensive, a high-stakes game of orbital billiards with no room for error. The Envisat, therefore, represents a critical turning point. It is a glaring symbol of our past carelessness and a powerful motivator for developing the new technologies and international agreements we will need to clean up the celestial junkyard we have created, ensuring that the pathways to space remain open for future exploration. But after the immediate and tangible threat of orbital debris like Envisat, we now turn to a concept that addresses a danger on a far grander scale, a threat from the deep solar system that has the potential to redefine life on our planet. This brings us to our next weird thing, which is fascinating because it isn't an object you can point a telescope at. Instead, it's an idea, a theoretical spacecraft known as the Great Attractor. This proposed vessel represents one of the most elegant and clever strategies for planetary defense, a method to gently nudge a threatening asteroid off a collision course with Earth without ever having to touch it. The core principle is deceptively simple, harnessing one of the most fundamental forces in the universe, gravity. The concept involves sending a spacecraft to rendezvous with a potentially hazardous asteroid. Instead of landing on it or blowing it apart, the spacecraft would simply station keep, holding a constant position near the asteroid for a very long time, perhaps years or even decades. Even though the spacecraft's mass would be minuscule compared to the asteroid's, its gravitational field would exert a tiny, continuous pull. Just as the Moon's gravity tugs on our oceans to create tides, the spacecraft's gravity would act as an invisible tow rope. By carefully maintaining its position, the spacecraft would slowly, inexorably drag the asteroid onto a slightly different trajectory. Over the immense distances of space, a velocity change of just a few centimeters per second, accumulated over years, could be enough to make a continent-sized miss instead of a direct hit. What makes this approach so brilliant is its fuel-free nature and its safety. Other proposed methods, like a kinetic impactor essentially slamming a spacecraft into the asteroid at high speed, carry the risk of fragmenting the object into multiple, still dangerous pieces. A nuclear explosive device presents even greater unpredictability. The gravity tractor, by contrast, is a gentle giant. It applies a force that is weak but perfectly controlled and constant. There's no explosion, no risk of breaking the asteroid apart. It's a scalable solution, too. A heavier spacecraft would exert a stronger pull, and the process could be used on a wide range of asteroid sizes. This method is particularly effective against the most common type of threat, asteroids rich in loose rubble, where a landing might be impossible and an impact could be ineffective. The gravity tractor works on the entire mass, regardless of its composition. This isn't just a thought experiment. The principles were partially demonstrated by NASA, a DART mission, which successfully altered the orbit of a small moonlet by crashing into it. While DART was a kinetic impact test, it proved that we can precisely affect an asteroid's path. A true gravity tractor mission would be the next logical step, a more delicate and sustained operation. Space agencies around the world are studying concepts for such spacecraft, often combining the gravity tractor idea with other tools. For instance, a spacecraft might first collect a large boulder from the asteroid's surface, thereby increasing its own mass and thus its gravitational pull, making it a far more effective tractor. The gravity tractor, as a concept, is a profound testament to human ingenuity. It represents a shift from brute force to subtle, intelligent application of physics. It turns a spacecraft from a simple projectile into a celestial shepherd, using the universal force of gravity itself to protect our world. It's a weird thing not because it's strange, but because it's so brilliantly simple, a silent, patient guardian that could one day park itself next to a mountain of rock hurtling through the void, and with the faintest of tugs, guide it safely past the pale blue dot we call home. After exploring the immediate dangers in Earth's orbit and the ingenious solutions we've devised to protect our planet, we now venture into a mystery that challenges our understanding of the entire cosmos on the grandest scale imaginable. Imagine watching leaves swirling in a river. You'd expect their motion to be chaotic, directed by the immediate currents and eddies around them. But what if you saw every single leaf across the entire river drifting in the same specific direction, pulled by some unseen, powerful undercurrent originating from a source far beyond the horizon? This is the essence of the phenomenon cosmologists call the dark flow. It is the controversial, spine-tingling observation that not everything in the universe is moving apart due to the expansion of space. Instead, immense clusters of galaxies, each containing thousands of galaxies, appear to be streaming in a coordinated, preferential direction, as if tugged by a gravitational force we cannot see and do not understand. The discovery of this potential cosmic current was made by studying the afterglow of the Big Bang itself, the cosmic microwave background radiation. This faint, uniform glow fills the entire sky, a cold relic of the universe's hot, dense infancy. Scientists used a subtle but measurable effect known as the kinetic Sunyaev-Zeldovich effect. As these massive galaxy clusters move through space, their hot gas clouds scatter the photons of the cosmic microwave background. This scattering imparts a tiny, specific signature, a slight shift in the temperature of the background radiation that acts like a cosmic speedometer, revealing the cluster's velocity and direction relative to the overall expansion of the universe. When a team of astronomers analyzed data from the Wilkinson Microwave Anisotropy Probe, they found something astounding. Hundreds of clusters, stretching out for billions of light years, seemed to share a common motion, all drifting toward a specific patch of the sky between the constellations of Centaurus and Vela. This motion was distinct from the local pull of the Great Attractor. It was a flow on a scale so vast it seemed to defy the fundamental cosmological principle that the universe should be homogeneous and isotropic, roughly the same in all directions, when viewed on a large enough scale. This finding, as one would expect, sent shockwaves through the cosmology community and ignited a fierce debate that continues to this day. The most straightforward explanation within our current model of the universe is that the gravitational pull of all the visible and dark matter we can observe should account for all large-scale motions. The dark flow suggests it does not. The clusters are moving too fast and too coherently to be explained by the mass we see, even when we include the immense gravitational influence of dark matter. This has led to some truly mind-bending theories. One of the most profound possibilities is that the dark flow is evidence of something entirely outside our observable universe, exerting a gravitational influence on us. The observable universe is just the part of the cosmos from which light has had time to reach us since the Big Bang. Beyond that horizon, there could be regions of space-time with vastly different densities or structures, perhaps even other universe domains in a hypothetical multiverse. The gravitational pull from a massive, unseen structure in this realm beyond our view could be the unseen hand tugging at these galaxy clusters, a ghostly signal from a cosmos we can never directly observe. Skeptics, however, have offered more conventional explanations. They argue that the detection method itself might be susceptible to unforeseen systematic errors, or that the data analysis could be misinterpreted. Subsequent studies using different instruments, like the Planck satellite, have failed to confirm the signal with the same strength, further fueling the controversy. The scientific process is one of rigorous verification, and the dark flow remains on the fringe, a tantalizing but unproven anomaly. Yet, its persistence in some datasets keeps it alive as an active area of research. It represents the cutting edge of cosmology, a potential crack in our standard model that could either be sealed with better data or pried open to reveal a deeper, stranger reality. Whether it is a monumental discovery or a monumental measurement error, the dark flow forces us to confront the ultimate limits of our knowledge. It asks us to consider what lies beyond the cosmic horizon and whether the universe we can see is merely a small island in an infinite ocean, subject to tides and currents whose sources are forever hidden from our view. Now, let's turn our attention from the grand, invisible currents of the cosmos to something surprisingly humble and yet incredibly pervasive, a type of space debris that is both beautiful and deadly. Drifting in the orbital pathways around our planet are countless shreds of what looks like silvery confetti or tattered, floating blankets. These are not alien artifacts or mysterious materials. They are fragments of multi-layer insulation, or MLI, a material as essential to a spacecraft as a suit of armor is to a knight. This is the strange story of the space blanket, a mundane piece of engineering that takes on a bizarre and hazardous second life when it escapes into the void. To understand why these bits of foil are so important, you have to picture the extreme environment of space. A satellite in direct sunlight can be scorched at temperatures well over 100 degrees Celsius, while the same object in shadow, exposed to the deep cold of space, can plummet to below -100 degrees. This wild temperature swing would quickly destroy sensitive electronics. The solution is multi-layer insulation. It's essentially a high-tech sandwich, often made of dozens of incredibly thin sheets of a remarkably durable plastic called ETFE, coated with a reflective metal like aluminum. Each layer is separated by a delicate mesh. This design works by creating a radiant barrier. The outer layer reflects the intense heat of the sun, while the inner layers trap what little heat the spacecraft generates, maintaining a stable, livable temperature inside. It's the same principle as a thermos, but engineered for the vacuum of space. Without this protective wrapping, our satellites and space stations would simply not function. But this life-saving material has a dark side. When a satellite is deployed, or when a rocket stage separates, small pieces of this insulation can tear loose. They might be ripped away by the violence of launch, or they might gradually degrade over years of being bombarded by micrometeoroids and relentless solar radiation. Once free, these shiny, flexible sheets become a permanent addition to the orbital debris population. What makes them particularly problematic is their enormous surface area relative to their tiny mass. They are like giant, flimsy sails. Even though they are lightweight, they can be pushed around significantly by the subtle but constant pressure of sunlight itself, a force called solar radiation pressure. This makes their paths through orbit highly unpredictable, far more so than a dense, solid piece of metal like a spent rocket engine. From a distance, a cloud of these fragments could be mistaken for something beautiful, a glittering, silent snowstorm encircling the Earth. But this is a deadly illusion, traveling at orbital velocities of 28,000 kilometers per hour. A postage stamp-sized piece of this foil carries the kinetic energy of a bowling ball thrown at highway speeds. A collision with an active satellite could puncture fuel tanks, shatter solar panels, or disable critical instruments. The real danger, however, lies in their potential to trigger a cascade. Because they are so light and numerous, a single collision involving a large piece of debris can create a massive cloud of these smaller fragments, each one now a new projectile capable of causing further collisions. This is the nightmare scenario of the Kessler syndrome, where low Earth orbit becomes so thick with debris that it becomes a dangerous and potentially impassable barrier. The longevity of this material adds to the problem. At higher altitudes, where there is no atmospheric drag to slowly pull objects down, these foil fragments can remain in orbit for centuries. They are a persistent pollutant, a testament to our presence that will long outlive the missions they were designed to protect. Tracking them is also a monumental challenge. Our radar and telescope networks are excellent at spotting objects larger than a softball, but the vast majority of these insulation shreds are far smaller, effectively invisible until it's too late. They represent the silent, accumulating cost of our exploration, a glittering, chaotic sea of human-made material that turns the vital space around our planet into an increasingly treacherous environment. After contemplating the silent, drifting dangers of orbital debris, our journey into the cosmic bazaar now uncovers a story of resurrection, a true testament to the stubborn endurance of human engineering. This is the tale of a satellite that refused to die, a NASA veteran that became a celestial zombie. Its official name was the International Sun-Earth Explorer 3, or ISEE 3, launched in August 1978 with a straightforward mission to study the interaction between the solar wind and Earth's magnetic field, acting as a sentinel at a gravitational balance point between our planet and the Sun. It performed this duty flawlessly for years, but its greatest adventures were still to come. In a brilliant piece of orbital gymnastics, NASA scientists used the Moon's gravity like a slingshot, catapulting the satellite out of its Earth-Sun orbit and onto a new path where it was reborn as the International Cometary Explorer, or ICE. Its new mission was historic. In 1985, ISEE became the first spacecraft ever to fly through the tail of a comet, specifically Comet Giacobini-Zinner, providing humanity with our first direct measurements of these icy wanderers. It then went on to observe Halley's Comet from a distance during its famous 1986 appearance. After these monumental achievements, its scientific work was largely done. NASA officially ended the mission in 1997, sending a final command to shut down its transmitters. ISEE 3, now ICE, was left to drift silently on a long, looping orbit around the Sun, a retired pioneer presumed lost to time. For 17 years, it was little more than a footnote in space history, a ghost in the machine. Then, in 2014, something incredible happened. A group of civilian engineers and space enthusiasts led by the organization SkyCorp and the crowd-funded project ISEE-3 Reboot, asked a daring question: what if the old satellite was still alive? They discovered that its orbit would soon bring it close to Earth again, presenting a once-in-a-lifetime opportunity. Their goal was audacious: to re-establish contact, reactivate its science instruments, and command it to fire its engines one more time, putting it back into a useful orbit. The challenge was immense. The satellite was built with 1970s technology. The original command software and hardware used to communicate with it had long since been dismantled and scrapped. It was like trying to speak a dead language with tools that no longer existed. Undeterred, the team turned to a remarkable resource: the Arecibo Observatory in Puerto Rico, one of the world's most powerful radio telescopes. They needed Arecibo's immense dish to broadcast a signal powerful enough to reach the distant satellite. But they couldn't just send any signal. They had to reverse engineer the exact protocols and codes that NASA used decades earlier. This meant digging through old paper documentation, tracking down retired engineers, and piecing together a communication system from scratch. After a frantic crowdfunding campaign and months of painstaking work, they achieved the impossible. In May 2014, they established two-way communication with the CMB satellite. It was still functioning, its systems having survived the harsh environment of space for 36 years, powered by solar panels that were still generating electricity. The cheers of triumph, however, were soon tempered by a harsh reality. The team's ultimate goal was to fire the spacecraft's engines to reposition it. But when they sent the command, they received devastating news. An essential part of the propulsion system, the nitrogen tanks needed to pressurize the fuel, were empty. Without this pressure, the engines were useless. The decades of temperature extremes had likely caused a leak, leaving the satellite incapable of course correction. ISEE-3 was alive, but it was paralyzed. They could talk to it and even collect some data from its still working instruments, but they could not steer it. It continued on its predetermined path, swinging past Earth and back out into the solar system. The story of ISEE-3 is more than just a fascinating technical feat. It's a profound lesson in longevity and legacy. This CMB satellite demonstrated the incredible robustness of early space hardware, built in an era before planned obsolescence, designed to withstand conditions we are only beginning to fully understand. Its brief resurrection also highlighted a shift in how we explore space, showing that passionate, determined civilians can directly interact with and learn from our orbital history. ISEE-3 continues its silent journey, and its orbit will bring it back near Earth in the 2029. Perhaps by then, another team of innovators, armed with even better technology, will be waiting to say hello once more to this enduring ghost from the dawn of the space age. Just when we thought we had a good grasp on the universe's grand architecture, a discovery emerges that seems to rewrite the rules. The giant arc is precisely such a find, a structure so immense it appears to challenge one of the foundational pillars of modern cosmology, the cosmological principle. This principle is essentially the scientific assumption that on the very largest scales, the universe is homogeneous and isotropic. In simpler terms, no matter where you are or which direction you look, the cosmos should appear roughly the same. It should be a fairly smooth, uniform soup of matter and energy. The giant arc, stretching a staggering 3.3 billion light-years across the sky, is a glaring contradiction to that idea, a cosmic eyebrow raised in question. This monumental structure wasn't discovered by looking at galaxies directly, but by using some of the most violent and energetic events in the universe as cosmic lighthouses, gamma-ray bursts. These are brief, cataclysmic explosions, often marking the death of massive stars or the collision of neutron stars. They are so phenomenally bright, they can be seen clear across the observable universe. A team of astronomers led by Alexia Lopez from the University of Central Lancashire used the light from these bursts to map the positions of distant galaxies. By analyzing data from thousands of these events, they noticed an improbable pattern. An immense, nearly symmetrical arc of galaxies was revealed, situated in the constellation of Boötes, so far away that its light has been traveling to us for over 9 billion years. To put its size into perspective, if you could hold it in the sky, the giant arc would appear as large as 20 full moons lined up side by side. Its scale is so vast, it encompasses approximately 1/15 of the radius of the entire observable universe. The sheer size of the giant arc is the source of its profound significance. Cosmologists have a theoretical limit for the maximum size of a coherent structure based on our understanding of how the universe evolved after the Big Bang. This limit is around 1.2 billion light-years. The giant arc is nearly 3 times larger than that. Finding such a gigantic feature is like stirring a cup of coffee and discovering that, instead of a uniform brown liquid, the cream has formed a perfect, unbroken spiral spanning the entire mug. It suggests that the processes in the early universe may have created far more pronounced wrinkles and concentrations of matter than our standard models can easily accommodate. This isn't just a larger-than-average cluster of galaxies. It is a thread in the cosmic web that seems impossibly long, hinting at influences and mechanisms we do not yet fully understand. Unsurprisingly, this discovery has ignited a fierce and ongoing debate within the astrophysics community. The first and most critical question is about the structure's statistical significance. Could such an arrangement simply be a chance alignment, a fluke in the data? The team's analysis suggests the probability of the arc forming by random chance is extremely low, but skeptics argue that the human brain is excellent at finding patterns, even when none exist, a phenomenon we saw with the face on Mars. Confirming the arc's reality requires more data from larger sky surveys to see if the pattern holds up under even closer scrutiny. If the giant arc is confirmed, the implications are staggering. It would force us to seriously reconsider the cosmological principle and the standard model of cosmology, known as lambda cold dark matter. This model has been incredibly successful at explaining a wide range of observations, from the cosmic microwave background to the accelerating expansion of the universe. However, the giant arc represents a potential crack in its foundation. It suggests that the universe might not be as smooth as we thought on its largest scales. There could be much larger variations in the density of matter, meaning our pocket of the cosmos might not be entirely representative of the whole. This opens the door to more exotic theories, perhaps involving unusual properties of dark energy or primordial energy fields that left an indelible imprint on the structure of space-time itself. The giant arc, therefore, is more than just a curiosity. It is a potential signpost pointing toward a deeper, and perhaps stranger, understanding of everything. From the grand, theoretical challenge of the giant arc, we now turn to a moment of pure human fallibility that had a surprisingly celestial consequence. It was a day of routine maintenance outside the International Space Station. In November 2008, astronaut Heidemarie Stephanician Piper was tasked with cleaning and lubricating a jammed rotary joint on the station's solar power system. During the intricate spacewalk, a crucial tool, a grease gun, began to leak inside her backpack-sized crew lock bag. As she worked to contain the mess, the entire bag, filled with other essential tools like scrapers and wipes, somehow slipped from her grip. In the weightless environment, there was no gentle fall to the ground. Instead, it simply drifted away, a silent, expensive tumble into the void. For a heart-stopping moment, she reportedly said, "Oh, great," as she watched an estimated $100,000 worth of equipment recede into the blackness, becoming an instant and unforgettable piece of space debris. What happened next, however, is what elevates this story from a simple anecdote of misfortune to a genuine cosmic oddity. The bag did not just vanish. The same physics that keeps the International Space Station in a stable orbit applied to the tool bag as well. It was moving at the same tremendous speed as the station, around 28,000 kilometers per hour. When it was released, it entered its own independent orbit around the Earth. For a few months, this lost satchel of tools became the brightest, most easily spotted piece of space junk in the sky. Amateur astronomers with modest telescopes could actually track it as it zipped across the heavens, a tiny, glinting dot preceding the much larger and brighter International Space Station by a few minutes. It was a bizarre sight, a human accessory, a symbol of mundane repair work, transformed into a temporary artificial satellite, orbiting our planet completely on its own. This incident serves as a powerful, real-world lesson in the unforgiving nature of the space environment. On Earth, dropping a tool means it lands at your feet. In orbit, that same mistake creates a new, independent celestial object with a life of its own. The tool bag's journey was spectacular but short-lived. Its orbit was just low enough that it experienced a tiny amount of atmospheric drag. Over the following months, this drag gradually slowed it down, lowering its altitude until, in August 2009, it finally succumbed to gravity and burned up harmlessly in the upper atmosphere over the South Pacific. Its fate was a best-case scenario for such an event, a clean and controlled exit that avoided adding a permanent hazard to the orbital pathways. The lost tool bag is more than just a funny story. It is a microcosm of the larger space debris problem. It demonstrates with stunning clarity how even the smallest, most human of errors can have a lasting impact beyond our atmosphere. Every screwdriver, every bolt, every lost glove becomes a hypervelocity projectile in orbit. While this particular bag is gone, countless other smaller fragments remain, each one a testament to the delicate and dangerous ballet we conduct just a few hundred kilometers above our heads. It reminds us that our presence in space is fragile, and that every action, no matter how routine, requires absolute precision, because in the void, there are no second chances to retrieve what gets away. After the lost tool bag, a story of a fleeting human error, we now confront a mystery imprinted on the very fabric of the cosmos, a cosmic bruise that has persisted since the dawn of time. This is the cold spot, an enigmatic and immense region of space that is significantly colder than its surroundings, a chilling anomaly discovered in the most ancient light we can observe, the cosmic microwave background. This afterglow is the cooled remnant of the Big Bang's initial fireball, a nearly uniform bath of radiation that fills the entire sky. It is our most precise snapshot of the infant universe, and for the most part, it is incredibly smooth, with only tiny, expected variations in temperature. The cold spot, however, is a glaring exception. It is a vast, circular patch in the constellation of Eridanus, about 1.8 billion light-years across, where the temperature dips in a way that standard cosmological models struggle to explain. When scientists first detected this anomaly in data from NASA's Wilkinson Microwave Anisotropy probe in 2004, and later confirmed it with the even more precise Planck satellite, the immediate task was to find a conventional cause. The leading hypothesis was that it wasn't a feature of the cosmic microwave background itself, but rather an effect created by something in the foreground. Imagine looking at a distant, uniformly bright wall through a giant, empty patch of window glass. If the glass had a subtle flaw, a region that was slightly less transparent, the wall behind it would appear dimmer in that spot. Astronomers proposed that the cold spot might be such a shadow cast by a colossal supervoid, an enormous region of space with a much lower density of galaxies and matter than average. As light from the cosmic microwave background travels through such a void, it would lose a tiny amount of energy climbing out of the void's weaker gravitational field, a phenomenon known as the integrated Sachs-Wolf effect. This energy loss would manifest as a slight cooling in the observed temperature. The hunt for this proposed supervoid began in earnest. Astronomers mapped the distribution of galaxies in the direction of the cold spot, and they did indeed find a large underdense region. But there was a critical problem. The void was not nearly big enough or empty enough to account for the dramatic temperature drop observed. It was like finding a small pothole and trying to blame it for the vibrations felt from a massive sinkhole. The mismatch between the observed coldness and the gravitational effect of the proposed void was so significant that it largely ruled out this straightforward explanation. The cold spot, it seemed, was not a shadow cast by an intervening structure. The chill appeared to be intrinsic to the cosmic microwave background itself, a genuine feature of the universe's baby picture. With the simplest answer failing, cosmologists were forced to consider far more exotic possibilities. One of the most mind-bending theories is that the cold spot is evidence of a collision with a parallel universe. This idea stems from the concept of the multiverse, a hypothetical collection of many universes existing alongside our own. In some versions of this theory, our universe is a vast bubble of space-time that inflated rapidly after the Big Bang. If another such bubble universe existed nearby during that inflationary period, it's conceivable that our bubble could have collided with it. The energy released in such a cosmic fender bender would have left a distinct imprint on the inner surface of our bubble, an imprint we would observe today as a circular, anomalously cold region on the cosmic microwave background. In this scenario, the cold spot is a cosmic scar, a bruise from a collision with another reality entirely. Of course, such a radical idea is met with healthy skepticism. The majority of physicists still favor explanations that reside within our own universe. Perhaps the cold spot is simply a rare statistical fluke. When you look at any random dataset, like static on a television screen, you will occasionally find unusually large areas of light or dark simply by chance. The universe is vast, and it's possible we are just in a position to observe a one-in-a-million anomaly that, while improbable, is not impossible. The challenge is calculating just how improbable it is. Some analyses suggest the cold spot has a chance of only 0.0002% of appearing in our standard model of the cosmos, making it a 5 sigma level anomaly, which is the gold standard for a discovery in physics. This enduring puzzle makes the cold spot a focal point for future observations. New telescopes, like the Vera-C Rubin Observatory, will conduct ultra-deep surveys of the galaxy distribution in that region, searching for any subtler vast structures we may have missed. More detailed studies of the cosmic microwave background's polarization, the direction in which its light waves vibrate, could also reveal telltale signs of whether the anomaly was caused by a primordial event like a universe collision. The cold spot remains one of the most significant unsolved problems in cosmology because it probes the very limits of our understanding. It forces us to ask whether our model of the universe is complete or if we are seeing the first faint hints of entirely new physics, or perhaps even evidence of a reality beyond our own. It is a cold, quiet question mark written in the oldest light there is, challenging us to decipher its origin. Now, let's shrink our perspective dramatically from the cosmic scale of the cold spot to a danger that is almost unimaginably small, yet carries the force of a freight train. In the pristine environment of space, the greatest threat often comes in the tiniest package. Consider a simple fleck of paint. On Earth, it's a harmless speck, something you'd wipe away with a rag. But launch that same fleck into orbit, and it undergoes a terrifying transformation, accelerated to velocities exceeding 17,000 miles per hour. It ceases to be a speck and becomes a hypervelocity projectile. The kinetic energy it carries is staggering. a particle no larger than a grain of sand, traveling at orbital speed, can strike with the energy of a bowling ball hurled down a highway. In the silent, airless void, there is no atmosphere to slow it down, no friction to burn it up. It moves with the relentless, unstoppable force of a bullet fired in a perfect vacuum. The evidence of this invisible barrage is etched into the very windows of our spacecraft. Perhaps the most visceral examples come from the retired Space Shuttle program. After each mission, ground crews would conduct meticulous inspections, and they frequently found the telltale signs of these microscopic impacts. The Space Shuttle's windows, made of incredibly strong fused silica and aluminosilicate glass, were often pockmarked with tiny craters. Some were mere divots, but others were significant chips, fractures radiating from a central point of impact. Each one was a silent testament to a near miss, a moment where a piece of debris, perhaps a flake of oxidized aluminum from an old rocket booster or a fragment of a shattered satellite, crossed paths with the orbiter at a relative speed faster than any bullet. NASA engineers became so concerned about the cumulative damage that they had to replace the windows regularly, a costly but necessary procedure to ensure the structural integrity and clarity needed for landing. This isn't just a historical footnote, it's a persistent and growing danger for the International Space Station. The station's modules are shielded with a sophisticated bumper system called Whipple shielding, designed to vaporize small particles on impact. But windows, solar arrays, and radiators cannot be as heavily armored. A strike in the wrong place could puncture a radiator, causing a critical loss of cooling, or shred a vital solar panel, crippling the station's power supply. For astronauts on a spacewalk, the risk is even more personal. Their spacesuits are their only protection, and while they are designed to withstand small micrometeoroid impacts, a larger piece of debris, even one just a few millimeters across, could cause a catastrophic depressurization. Every spacewalk is conducted with the unspoken awareness that an invisible swarm of shrapnel is whizzing past, a reminder that humanity's foothold in orbit is a fragile one, constantly under siege by the ghosts of our own technological ambition. The story of this fleck of paint is a powerful lesson in scale and consequence. It forces us to realize that the problem of space debris is not just about avoiding entire dead satellites like Envisat. It is about managing a cloud of millions of tiny fragments, each one capable of causing catastrophic failure. Tracking these objects is a monumental challenge. Our surveillance networks can reliably spot objects down to the size of a softball, but the vast majority of the threat is far smaller and utterly untrackable. There are the landmines of low Earth orbit, invisible and unpredictable. This ever-present danger dictates mission planning, requiring spacecraft to perform regular avoidance maneuvers and adding a layer of constant risk to every venture beyond our atmosphere. It is a humbling thought that the future of space exploration may depend as much on our ability to clean up our smallest messes as it does on our capacity to build grand new machines. While our journey has taken us past cosmic clouds and through orbital graveyards, some of the most profound weirdness is found not in the void, but on the ground of another world, hiding in plain sight. After the nail-biting drama of a lost tool bag or the silent threat of a fleck of paint, the story of the Martian blueberries offers a different kind of tension, the slow, patient unraveling of a planetary mystery. When NASA Opportunity rover bounced to a stop on the Meridiani Planum in January 2004, its cameras immediately revealed a landscape that was both alien and strangely familiar. The rusty soil was littered with countless tiny, grayish spherules scattered across the surface like a child's marbles or a vast field of misplaced ball bearings. The rover team, captivated by their appearance, promptly nicknamed them blueberries, though their color was more reminiscent of gunmetal than the sky. These weren't just interesting rocks, They were a geologic puzzle. Their near-perfect spherical shape was the first major clue. On Earth, such perfect spheres in nature are rarely formed by volcanic processes or simple erosion. Instead, they often point to a very specific origin: water. The rover's onboard instruments, specifically its alpha particle X-ray spectrometer, soon confirmed the blueberries' composition. They were made almost entirely of hematite, an iron oxide mineral. While hematite can form in several ways, one of the most common processes on Earth requires the presence of liquid water. The hypothesis began to take shape that these blueberries were concretions. Imagine mineral-rich water seeping through porous rock. Over immense stretches of time, the dissolved minerals, in this case iron compounds, begin to precipitate out of the water, collecting around a central nucleus, a tiny grain of sand or a minuscule crystal. Layer by microscopic layer, the mineral builds up in all directions equally, eventually forming a perfect sphere, much like a pearl growing around a grain of sand in an oyster. The implications of this simple explanation were staggering. The blueberries weren't just a curious surface feature, they were fossilized droplets of Mars's history. They served as robust, durable proof that the dry, dusty, and bitterly cold landscape opportunity was traversing had once been a very different place. This region was likely the bed of an ancient, shallow, salty sea or a system of groundwater-saturated sediments. The hematite concretions formed underground, within these wet layers, and then, over billions of years, the softer surrounding rock was gradually eroded away by the Martian wind, leaving the incredibly hard blueberries behind to litter the surface like geological confetti. They became a time capsule, preserving within their layered structure the chemical signature of a vanished environment, one that was potentially habitable for microbial life. What makes these tiny spheres so profoundly weird, beyond their unexpected perfection, is their sheer abundance. They weren't confined to one small area. They were everywhere opportunity looked, often densely packed into the rock outcrops themselves, earning the nickname Blueberry Muffin Rock. Their uniform size, typically just a few millimeters in diameter, suggests the conditions that form them. The chemistry of the water, the temperature, the pressure, were stable and widespread across a vast region for a very long time. This wasn't a fleeting puddle, it was a sustained, planet-wide process. The blueberries of Mars are a quiet but powerful testament to the planet's dynamic past. They're a reminder that the most extraordinary discoveries aren't always colossal structures or anomalous signals. Sometimes they are small, round, and iron-rich, telling a story of a world that was once blue with water, not just red with dust. While the cosmos presents us with grand mysteries and colossal dangers, one of the most persistently weird challenges of living in space is also the most fundamentally human. We've conquered rocket science and mastered orbital mechanics, but the simple, unavoidable reality of human biology remains a complex puzzle. This brings us to a subject that is at once mundane, bizarre, and absolutely critical for survival: the management of astronaut waste, particularly what has been informally dubbed the space poop problem. On the International Space Station, the solution for solid waste is both practical and strangely poetic. After astronauts do their business, the waste is collected, stored in special containers, and eventually loaded onto a departing cargo spacecraft, like a Cygnus or a Progress vehicle. These uncrewed ships are then deliberately guided to burn up entirely in the Earth's atmosphere. In a very literal sense, every few months, a small portion of the ISS, this trash including this very human refuse, is transformed into a brief, incandescent meteor shower, a silent and private disposal system that turns a biological necessity into a fleeting streak of light. But this elegant solution only works for a space station with regular resupply missions. The real challenge, the one that pushed NASA to think outside the box, emerges during long-duration activities where an astronaut cannot simply return to a cabin, such as during a multi-hour spacewalk inside a pressurized suit or on a future journey to Mars. Imagine being sealed inside a spacesuit for 8, 10, or even 12 hours. There is no option to take a break. For decades, astronauts have relied on what's known as a maximum absorbency garment, which is essentially a highly sophisticated adult diaper. It's a functional, but far from ideal, solution, especially when considering missions that could last days in a suit in the event of an emergency. Discomfort, the risk of skin infections, and the sheer unpleasantness of the situation presented a significant hurdle for the next era of exploration. This pressing need led NASA to do something quite extraordinary in 2016. Rather than keeping the problem in-house, they turned to the global public for help. They launched the Space Poop Challenge, an open innovation contest hosted on a platform called Hero X. The goal was deceptively simple: design a system that could handle the collection and containment of astronaut waste, both urine and feces, inside a spacesuit for up to 144 hours, or 6 full days. The system had to be hands-free, operate in microgravity, and cause no harm to the astronaut. The challenge wasn't just about engineering, it was about human factors, requiring a solution that was not only effective, but also dignified for the person relying on it in a vulnerable situation. The response was overwhelming and brilliantly creative. Over 5,000 entries poured in from a diverse range of thinkers, including engineers, doctors, and even fashion designers. The winning design, submitted by a flight surgeon named Thatcher Carton, was a masterpiece of minimalist ingenuity. His system involved a small, sterile airlock-like port, no larger than a coin, integrated into the suit's groin area. Inside, a tiny, inflatable catheter would handle liquid waste, while for solid waste, the system used a mechanism similar to a tiny medical scope to gently suction the waste away from the body and into an airtight bag, all while maintaining the suit's internal pressure. It was a concept that prioritized both hygiene and the astronaut's psychological comfort, addressing a problem that had been a quiet nuisance since the earliest spacewalks. The Space Poop Challenge is a weird but wonderful example of how solving the most basic human problems is just as important as navigating the stars. It underscores a profound truth about space exploration. It is not just a story of technology and physics, but one of biology and human resilience. Before we can establish a base on the moon or send humans to Mars, we must first master the art of taking care of our own bodies in the most hostile of environments. This contest demonstrated that sometimes the most innovative solutions come from looking at an old problem from a completely new angle, and that no challenge, no matter how undignified it may seem on Earth, is too small to warrant a brilliant solution when the goal is the future of humanity in space. Amidst the grand spectacle of a rocket launch, as fiery plumes tear at the sky and a colossal machine fights its way to orbit, there are moments of violent, precisely choreographed separation. To shed the dead weight of an empty fuel tank, a rocket must break itself apart mid-flight, and it does so with a series of explosive charges. These are not bombs in the destructive sense, but highly controlled devices called frangible bolts or pyrotechnic fasteners. Imagine a specially designed nut and bolt, engineered with a pre-weakened groove. When a small explosive charge embedded within it is triggered, the bolt shatters cleanly in two, releasing whatever massive structure it was holding in place. In that instant, a rocket stage weighing several tons is set free to fall back to Earth. But the story doesn't end there. The very mechanism that enables this crucial step has a strange and lingering afterlife. Attached to these separation points are often rings or shields known as bolt catchers. Their job is to capture the fragments of the shattered bolts, preventing them from flying wildly and damaging the delicate spacecraft or the second stage engine nozzle. However, the entire assembly, the ring that holds the bolts, the casing for the explosive charges, is itself jettisoned. After the bolts fire and the stage is separate, these now empty metal rings are cast off into the void. In an instant, they transform from a critical piece of engineering into anonymous space junk. They are the ghostly remnants of a rocket's transformation, silent witnesses to a moment of incredible power that now drift on their own independent paths around the planet. What makes these objects particularly bizarre is their dual nature. They are, by design, meant to be discarded. Their creation and release are a sign of a successful launch. Yet, each one represents a permanent addition to the growing cloud of orbital debris. They are typically small, irregularly shaped, and incredibly difficult to track with radar. Unlike a large, dormant satellite, whose orbit can be precisely predicted, these ghost bolts and their catcher rings tumble erratically. Their small size and complex shapes make them susceptible to the subtle push of solar radiation pressure, causing their trajectories to shift in unpredictable ways over time. They become, in effect, invisible landmines in the heavily trafficked orbital highways. The profound irony is that these objects, born from an act of brilliant engineering intended to make spaceflight possible, now contribute to making the space environment more dangerous for future missions. A collision between an operational satellite and one of these anonymous rings, each traveling at orbital velocities exceeding 17,000 miles per hour, would be catastrophic. The resulting cloud of shrapnel would itself spawn countless new collision hazards, exacerbating the risk of a cascading chain reaction known as the Kessler syndrome. These ghost bolts, therefore, are a powerful symbol of a fundamental challenge in space exploration. Our every step forward often leaves a permanent and potentially problematic footprint. They are the unintended consequences of our ambition, silent echoes of the explosive violence required to reach the stars, now forever circling Earth as a permanent and perilous monument to our ingenuity. Journey with me now to the very heart of our galaxy, to a place of unimaginable darkness and violence, where the laws of physics seem to be pushed to their breaking point. Orbiting the supermassive black hole known as Sagittarius A star, a monster with 4 million times the mass of our Sun, is a family of stars that simply should not exist. Astronomers call them the S-stars, and their existence is one of the most baffling enigmas in modern astrophysics. These are not ancient, dying suns. They are stellar infants, cosmically speaking, massive, brilliant, and young, blazing with a ferocious intensity. The puzzle is not their youth, but their address. They are dancing in a celestial graveyard, circling perilously close to the black hole's event horizon, a region where the gravitational tides are so powerful they should have shredded any potential star, forming cloud long before it could ever coalesce. The orbits of these stars are a spectacle in themselves, a dizzying celestial ballet mapped with breathtaking precision by telescopes like the Keck Observatory in Hawaii. Using adaptive optics to cut through the blurring effects of our atmosphere, astronomers have tracked individual stars for decades. We've watched as one star, known as S2, completes a full orbit in just 16 years, a journey that takes it swooping around the black hole at a staggering speed of over 5,000 kilometers per second at its closest approach. That's nearly 3% the speed of light. To survive this blistering elliptical sprint, the star must be incredibly robust, a testament to the sheer binding force of gravity. But the real mystery is how it got there in the first place. The conventional model of star formation involves a vast, relatively peaceful cloud of gas and dust collapsing under its own gravity. Near Sagittarius A star, however, any such cloud would be stretched and torn apart by the black hole's immense tidal forces long before it could ever fragment into a star. It's like trying to build a sandcastle in the middle of a hurricane. So how did these stellar daredevils end up in such an impossible neighborhood? Astronomers have proposed two leading theories. each with its own compelling narrative. The first is a story of cosmic migration. Perhaps these stars were not born in the hostile environment near the black hole, but instead formed in a more conventional stellar nursery much farther out, in a dense cluster of sibling stars. Over millions of years, complex gravitational interactions within this cluster could have acted like a slingshot, flinging some stars outward into the galaxy, while hurling others, like S2, inward on a fatalistic trajectory toward the central black hole. Against all odds, these stars ended up in stable, if highly eccentric, orbits rather than being devoured. This theory paints a picture of the galactic center as a dynamic, gravitational pinball machine, where stars are constantly being shuffled and dealt into new orbits. The second theory is even more dramatic, suggesting that star birth is possible even in the face of such overwhelming destructive power. This scenario envisions a massive, dense disk of gas spiraling into the black hole. If this disk is sufficiently dense and cools rapidly enough, its own self-gravity could overcome the black hole's tidal forces, causing it to fragment and collapse directly into stars. This would be star formation on hard mode, a rushed, violent process happening under extreme duress. The resulting stars would be born on the run, already locked into orbits around the monster that tried to tear them apart. This idea turns our understanding of stellar nurseries on its head, suggesting that under the right conditions, stars can ignite even in the most forbidding of crucibles. The intense study of these impossible stars is about more than just solving an orbital puzzle. It's a unique laboratory for testing Einstein's theory of general relativity. The extreme gravity around Sagittarius A star subtly alters the path of these stars in ways Newtonian physics cannot explain. Precise tracking of S2's orbit has already revealed a slight precession, a rosette-shaped pattern in its path, which matches the predictions of general relativity with stunning accuracy. By continuing to watch this dangerous dance, we are not only unraveling the origin story of these stellar survivors, but also probing the very nature of space and time in the most extreme environment our galaxy has to offer. They are lighthouses in the dark, illuminating the fundamental laws that govern the universe from the one place we thought nothing could possibly shine. Leaving behind the gravitational extremes of our galaxy's heart, we now travel to the quiet, frozen fringe of our own solar system, to an encounter that gave us our first clear look at the primordial building blocks of planets. After its historic flyby of Pluto in 2015, NASA's New Horizons spacecraft was still hurtling outward, its mission far from over. Scientists aimed it toward a distant, mysterious object known then as Ultima Thule, a name meaning beyond the known world. As New Horizons approached on New Year's Day 2019, the world waited to see what this ancient relic would reveal. The first images, transmitted across billions of miles, resolved from a blurry pixel into a shape that was both whimsical and profoundly strange, a perfect cosmic snowman. This object, now officially named Arrokoth, a word meaning sky in the Powhatan/Algonquian language, turned out to be one of the most pristine and important fossils ever discovered, not buried in rock on Earth, but floating serenely in the deep freeze of the Kuiper Belt. Arrokoth's snowman appearance is deceptively simple. It is what astronomers call a contact binary, consisting of two distinctly separate lobes that are gently fused together. The larger lobe, nicknamed Ultima, is flatter, almost like a giant pancake, while the smaller lobe, Thule, is more shaped like a dented walnut. This bizarre, flattened structure was a complete surprise. Most models of such distant objects predicted they would be more spherical. Their connection is not a violent crash site, but a gentle merger. The two lobes show no signs of the intense scarring or compression you would expect from a high-speed collision. Instead, the evidence points to a remarkably slow and graceful dance. Billions of years ago, these two separate bodies, each formed from a local cloud of dust and ice, orbited each other in a slow, stately waltz. Over eons, their orbits decayed, and they drifted closer and closer until they finally touched, merging at a speed comparable to a gentle walking pace. This peaceful union preserved their individual shapes, creating the celestial snowman we see today. What makes Arrokoth so incredibly valuable is its profound isolation. Located about 4 billion miles from the Sun in the Kuiper Belt, a vast reservoir of icy bodies beyond Neptune, it has resided in a deep freeze storage for the entire 4.5 billion year history of the solar system. It is a time capsule of almost unimaginable purity. While planets like Earth have been transformed by geological activity, impacts, and the presence of life, Arrokoth has remained virtually unchanged since its formation. Its surface, revealed in stunning detail by New Horizons, is uniformly red, likely colored by complex organic molecules called tholins, which are created when simple ices like methane and water are irradiated by cosmic rays over billions of years. This reddish hue is a badge of antiquity, a sign of an object that has been untouched by the internal heat or atmospheric processes that alter worlds closer to the Sun. Studying Arrokoth is like opening a textbook to the very first chapter on how planets are built. Its two-lobed structure provides direct evidence for a key theory of planetary formation called hierarchical accretion. This model suggests that planets did not form from the sudden collapse of giant clouds, but through a gradual, step-by-step process. First, tiny dust grains stuck together. Then, these clumps collided gently to form pebbles, then rocks, and then larger bodies known as planetesimals, which were the building blocks of planets. Arrokoth is one of those fundamental planetesimals, frozen in the act of its own creation. Its smooth neck, the region where the two lobes join, suggests that the object was once surrounded by a cloud of fine dust that settled into the gravitational basin between them, a process predicted by models, but never before seen so clearly. The New Horizons flyby transformed Arrokoth from a faint point of light into a world with a detailed geological history. The absence of craters, fractures, or any significant surface features tells its own story. It has led an exceptionally quiet life, undisturbed by the chaotic gravitational shuffling that affected objects in the inner solar system. This peaceful existence makes it a benchmark, a pristine sample against which we can compare all other solar system bodies. Every asteroid, every comet, every moon has been shaped by violence and heat to some degree, but Arrokoth is different. It is the blank canvas, the original recipe, showing us the raw ingredients from which our entire planetary system was constructed. This weird, flattened snowman, drifting in the eternal twilight of the Kuiper Belt, is therefore much more than a curiosity. It is a direct messenger from the dawn of our solar system, offering a humbling glimpse into the gentle, step-by-step process that eventually led to the formation of planets, and ultimately to us. After exploring the frozen fossil that is Arrokoth, our attention now turns to a far more local, yet equally baffling, phenomenon painted in light and shadow upon the face of our closest celestial neighbor. Scattered across the moon's dark volcanic plains, known as Maria, are ethereal features that look like cosmic graffiti, the lunar swirls. The most famous of these, Reiner Gamma, is a brilliant, high-contrast marking that resembles a delicate, swirling cloud or a phantom whirlpool frozen into the lunar soil. From orbit, it presents a stunning visual paradox. While most lunar features are defined by the play of light and shadow across craters and mountains, the swirls appear bright and dark entirely independently of the topography. They are painted onto the landscape, their intricate, curving patterns seeming to ignore the hills and valleys beneath them, as if an invisible artist used a celestial airbrush to decorate the moon's surface. The leading explanation for these enigmatic markings involves an invisible force field and a relentless, abrasive wind. The Moon has no global magnetic field to protect it from the charged particles constantly streaming from the Sun, known as the solar wind. This relentless bombardment has a darkening effect on the lunar soil, or regolith, over billions of years. It causes a process called space weathering, where the iron-rich minerals in the soil are gradually broken down, creating tiny metallic nanoparticles that give the mature lunar surface its characteristic dark gray color. However, when scientists mapped the lunar swirls, they discovered a remarkable correlation. Each bright swirl is directly overlain by a localized, surprisingly strong magnetic field. These miniature magnetic bubbles, embedded in the lunar crust, act like tiny protective shields. They deflect the solar wind, preventing it from reaching the soil directly beneath them. As a result, the soil within the swirls remains immature, its original, brighter color preserved, while the surrounding soil is steadily darkened. It's as if these magnetic patches have created permanent umbrellas, leaving behind a bright negative image of their protective shape. But this elegant solution only deepens the core mystery. If the magnetic fields create the swirls, what created the magnetic fields? The Moon's core is too small and inactive to generate a global magnetic dynamo like Earth's, and it certainly cannot produce these isolated, powerful patches. This is where the debate truly begins. One compelling theory points to a violent and ancient origin. When large asteroids slam into the Moon, they create immense impact basins. The titanic force of such a collision can vaporize a significant amount of rock, creating a superheated, ionized cloud of plasma. In the chaotic aftermath, as this plasma swirled and cooled, it could have generated a powerful, transient magnetic field. As the underlying rocks cooled and solidified, this magnetic signature could have become permanently locked into certain minerals, like iron, within the crust, creating the magnetic anomalies we detect today. In this scenario, the beautiful swirl of Reiner Gamma could be the ghostly imprint of a cataclysm that occurred billions of years ago. A second, even more intriguing hypothesis involves subterranean magic. Some scientists propose that these magnetic fields are the remnants of ancient magma flows. Billions of years ago, when the Moon was still geologically active, lava welled up from the interior to fill the giant impact basins, forming the Dark Maria. As this iron-rich lava cooled very slowly through a specific temperature threshold known as the Curie point, the iron minerals within it could have become magnetized by any ambient magnetic field that existed at the time, perhaps from an early, temporary lunar dynamo. If the cooling lava contained certain compositions that made it particularly adept at retaining this magnetism, it could have left behind these magnetic fossils. The swirl patterns would then map the complex, swirling patterns of the now buried lava flows, their magnetic signatures subtly influencing the surface, weathering for eons to come. The lunar swirls thus stand as a breathtaking example of a mystery with layers. We have a well-understood mechanism for their appearance: the deflection of the solar wind by magnetic shields. Yet the origin of those shields themselves remains an active field of scientific detective work. They are a beautiful reminder that even our familiar Moon, a world we have walked upon, holds profound secrets. Future missions, perhaps involving rovers capable of directly studying the soil within and outside the swirls, will be crucial for pinning down their true origin. For now, they remain one of the solar system's most elegant and silent puzzles, a testament to the fact that sometimes the most striking beauty arises from the most complex and hidden forces. While many of the objects in our cosmic collection are natural wonders or mysterious anomalies, the 26th entry is a hauntingly human artifact, a ghost from the very dawn of our push toward the Moon. Drifting in a chaotic orbit between Earth and its celestial partner is a piece of history that was lost for decades, a dead NASA Centaur rocket booster. This specific upper stage has a precise pedigree. It was the launch vehicle for the Surveyor 2 mission in September 1966, a robotic scout sent to soft land on the lunar surface and paved the way for the Apollo astronauts. But the mission was doomed. A mid-course correction failure sent the lander tumbling, causing it to crash into the moon. The Centaur booster, its job complete, sailed past our satellite and into an anonymous solar orbit, disappearing from human awareness as completely as a ship vanishing into a foggy sea. For 36 years, this metallic cylinder, roughly the size of a school bus, was just another unseen piece of debris in the vastness. Then, in September 2002, astronomers with the Lincoln Near-Earth Asteroid Research Project in New Mexico detected a faint, moving object. Their automated sky surveys are designed to find asteroids whose paths could potentially bring them hazardously close to Earth. This new discovery, given the provisional asteroid designation J002E3, initially appeared to be just that. But as they tracked its path, something didn't add up. Its orbit was strange, not quite like any natural asteroid they had seen before. The clues began to mount, pointing toward a much more intriguing origin. The object's reflectance spectrum, the way it reflected sunlight, suggested a surface of white titanium dioxide paint, a common coating for spacecraft, not the dark, rocky surface of a typical asteroid. Furthermore, its orbit was influenced by slight, non-gravitational forces, a tiny push that could be explained by the subtle but constant pressure of sunlight on a large, hollow man-made object. The mystery was finally solved by orbital dynamicist Paul Chodas at NASA, a jet propulsion laboratory. By running the clock backwards on a powerful computer model, he traced the object's path through the solar system over the intervening decades. The digital trajectory intersected perfectly with the Earth-Moon system in September 1966. There was only one object launched at that time that matched the story: the Centaur booster from the ill-fated Surveyor 2 mission. The lost had been found. What was once a potential near-Earth asteroid was reclassified as a relic of human exploration, a confirmation that transformed it from a subject of planetary defense into a monument of spaceflight history. This case of mistaken identity highlights a fascinating modern phenomenon. As our ability to scan the skies improves, we are increasingly finding our own discarded technology returning to us, disguised as natural celestial bodies. The booster's orbit is a fascinatingly complex and unstable dance, a direct result of its initial lunar flyby. It doesn't follow a simple, predictable ellipse around the sun. Instead, it occupies a gravitational corridor where the combined tugs of Earth and the Moon create a chaotic pathway. This results in a pattern where it sometimes loops around the Earth for a few years, acting almost like a temporary, irregular moon, before being flung back out into a wider solar orbit. Its distance from us varies wildly. At times, it ventures far away, while during its close approaches, it can come within the Moon's orbit, making it bright enough to be seen with moderate telescopes. During these periods, it becomes a frequent target for astronomers, not for fear of impact, but for the unique opportunity it presents. They use radar to bounce signals off its surface, creating detailed images that reveal its cylindrical shape and confirm its artificial nature. These observations also help scientists precisely track its movements, providing invaluable data on how objects behave in these chaotic gravitational zones. This Centaur booster is far more than just an old piece of space junk. It is a silent witness to the Apollo era, a tangible connection to a time of audacious ambition and rapid technological progress. It was part of the crucial groundwork that made the moon landings possible. Now, it circles the sun as a permanent, if unintended, monument to that effort. Its chaotic path ensures it will periodically revisit the Earth-Moon system for centuries, perhaps even millennia, to come. It serves as a poignant reminder that our explorations leave lasting marks on the solar system. The footprints on the moon may fade in a million years, but this ghost rocket, this metallic tombstone for a failed mission, will continue its lonely voyage long after our civilization is gone, a testament to the first time humanity reached beyond its home world and left a piece of itself adrift in the cosmic ocean. But as we look at these ghostly remnants of past missions, our attention shifts to a piece of modern spaceflight that is designed for destruction from the very start. In the intricate ballet of resupplying the International Space Station, one of the most dramatic and final acts belongs to the SpaceX Dragon capsule's disposable trunk. After a month or more docked to the station, its cargo of science experiments and supplies unloaded and replaced with Earth-bound trash, the Dragon capsule prepares for its return journey. It undocks, fires its engines to slow down, and plunges back into the atmosphere for a parachute-assisted splashdown, but it doesn't make that journey whole. Just before the final descent, a series of pyrotechnic bolts fire, and the entire cylindrical rear section of the spacecraft is jettisoned into space. This is the trunk, and its fate is a foregone conclusion, a fiery, complete disintegration in the upper atmosphere. For a brief period, however, it exists as one of the largest and most peculiar temporary objects in orbit, a massive, empty shell silently tracing a path around the planet. To understand why this happens, you have to look at the Dragon's unique design. Unlike many other cargo vehicles that burn up entirely, the Dragon capsule is reusable. Its pressurized section, the bell-shaped cabin that carries cargo, is designed to be recovered, refurbished, and flown again. The trunk, however, is purely functional for the orbital phase of the mission. It's an unpressurized cylinder with a skeletal nose cone that opens after launch to reveal a standard docking adapter. Its primary jobs are to provide power and cooling. The two long solar panels that unfold like wings are mounted on its sides, and the radiators that shed the spacecraft's excess heat are embedded in its walls. It also carries unpressurized cargo in its cylindrical cavity, items that don't need to be brought inside the station, like new satellites for deployment. But once the Dragon leaves the station, the trunk's work is done. The solar panels are no longer needed, the radiators are inactive, and it becomes dead weight. Bringing it back through the atmosphere would be pointless. Its fragile structure would not survive re-entry, and its sheer size would complicate the capsule's aerodynamics and heat shield protection. So it is cast off, a necessary sacrifice for a successful homecoming. What's truly strange is the brief afterlife of this discarded component. For a period ranging from a few months to, in some cases, over a year, the empty trunk continues to orbit the Earth. Stripped of its purpose, it is a ghost of its former self, a hollow cylinder about 4 meters in diameter and 6 meters long, tumbling slowly in the silence. It contains nothing but a few mounting brackets and the faint memory of the cargo it once held. Its orbit is typically low enough that it's constantly brushing against the wisps of the upper atmosphere, which gradually but inexorably drag it downward. During this time, it is a significant, albeit short-lived, piece of space debris. Its large surface area makes it relatively easy to track, but its empty, lightweight construction also makes its path slightly unpredictable, susceptible to the subtle push of solar radiation pressure. There's a profound symbolism in the trunk's existence. It represents the pragmatic, almost brutal efficiency of modern space logistics. It is a piece of advanced engineering, meticulously built and tested, only to be used once and then deliberately thrown away. This is the reality of spaceflight. For every glorious launch and every successful splashdown, there is a trail of discarded hardware. The trunk is not a tragic loss like the lost tool bag. Its death is planned. It is a consumable, an integral part of the mission's cost calculus. Yet, in that window between separation and destruction, it becomes a temporary monument to that very pragmatism. It is a blank slate, a canvas upon which one could project any number of thoughts about our throwaway culture, even as it extends beyond our planet. This cycle of creation and disposal is a constant in our reach for orbit. The Dragon's trunk is just the latest iteration of a practice that began with the jettisoned rocket stages of the 1960s, but its regularity, with multiple Dragon missions flying each year, means that at any given moment, there are several of these large, empty cylinders in various stages of their decay toward a final, brilliant flash in the sky. They are a reminder that our presence in space is not clean, it is messy, and requires a constant process of letting go. The trunk serves its purpose flawlessly, and its design demise is a key part of the Dragon capsule's success. It is a weird, transient artifact of our orbital age, a large and empty shell that briefly shares the sky with satellites and stations before gracefully making way for the next mission. But perhaps the most spectacular example of this galactic interaction is the vast, invisible component of the Whale Galaxy, its colossal halo of hot gas. Observations from space-based X-ray telescopes have revealed that ISEE 4631 is shrouded in an immense, diffuse cloud of superheated gas that extends for hundreds of thousands of light years into intergalactic space. This halo glows not in visible light, but in high-energy X-rays, a testament to its multi-million-degree temperature. This gas is believed to have been blown out of the galaxy by the combined fury of its starbirth, the powerful stellar winds from massive stars, and the shockwaves from countless supernova explosions. It is a galactic-scale wind, a testament to the immense energy being generated within the Whale's star-forming factories. This process, known as a galactic fountain, is crucial for enriching the space between galaxies with heavy elements forged in stellar cores, seeding future generations of stars and planets. The Whale Galaxy, therefore, is not just a static sculpture. It is a dynamic engine, actively expelling its own processed material back into the cosmos. Its strange, warped shape is a direct result of a violent, ongoing life cycle, a beautiful and destructive dance with its neighbors that paints a picture of galaxies not as isolated islands, but as interactive, evolving communities in the vast ocean of the universe. Now we turn our eyes from the grand, ancient structures of the cosmos to a spectacle that is entirely new, a phenomenon born in the last few years that has begun to rewrite our experience of the night sky itself. It is a sight that has startled countless backyard stargazers and professional astronomers alike, a string of brilliant, unblinking points of light, moving in a perfect, silent procession across the twilight or the deep night. This is the Space Pearl Necklace, the stunning visual effect created by a train of communication satellites, like those of SpaceX's Starlink constellation, shortly after their launch. Before they climb to their final, higher orbits and spread out across the globe, these dozens of satellites travel together in a tight formation, their large, flat antennas perfectly angled to catch the sun's rays, even while the ground below is in darkness. The result is a temporary, ethereal necklace of light, a starkly artificial yet undeniably beautiful addition to the celestial dome. The creation of this pearl necklace begins with a technological marvel. A single Falcon 9 rocket launches a stack of 60 or more flat-packed satellites into a preliminary, low-altitude orbit. For the first few days or weeks after deployment, these satellites are at their brightest. They are still close to Earth, and their orientation often means they act like a fleet of tiny, distant sails, reflecting a tremendous amount of sunlight toward the ground. As they follow their initial orbital path, they appear as a linear convoy, sometimes stretching across a significant portion of the sky. The effect is most pronounced in the hours after sunset or before sunrise, when the observer on the ground is in darkness, but the satellites, orbiting hundreds of kilometers high, are still bathed in full sunlight. This precise alignment creates a window where they become the brightest man-made stars in the heavens, outshining all but the brightest planets and actual stars. However, this beautiful spectacle is at the heart of a profound and ongoing controversy within the scientific community. For astronomers, both professional and amateur, the pristine darkness of the night sky is not just a source of beauty, it is an essential laboratory. The arrival of these mega-constellations, which aim to number in the tens of thousands, represents an unprecedented threat to their work. The problem is twofold. First, the bright satellite trails can easily saturate the sensitive detectors of large telescopes like the Vera-C Rubin Observatory, which is designed to scan the entire sky repeatedly to detect faint, fleeting objects like near-Earth asteroids or distant supernovae. A single bright streak from a satellite can obliterate the data collected during that exposure, rendering it useless. It's like trying to study the fine brush strokes of a painting while someone repeatedly flashes a bright light across the canvas. Second, and perhaps more insidiously, is the impact on radio astronomy. Many of these satellites operate in radio frequencies that are crucial for studying the universe. The faint whispers from the cosmic microwave background, the signals from distant pulsars, and the spectral lines of interstellar molecules can be drowned out by the radio chatter from thousands of satellites passing overhead. Radio observatories, which are often built in remote locations specifically to escape human-made radio interference, now find their quiet zones encroached upon from above. The astronomical community has raised the alarm that we are on the cusp of fundamentally altering our view of the cosmos, potentially losing access to certain wavelengths and deep sky observations forever, all for the sake of global internet connectivity. In response to the backlash, companies like SpaceX have been actively working on mitigation strategies. They have experimented with DarkSat, applying a special anti-reflective coating to the satellites to make them less bright. A more promising solution has been the development of VisorSat, a design that incorporates a sunshade, much like a baseball cap's visor, that deploys once in orbit to block sunlight from hitting the most reflective parts of the satellite. Early observations suggest these visors have been effective at reducing the satellite's brightness to a level that is less intrusive, though they are still visible to the naked eye and can still pose challenges for the most sensitive telescopes. This represents a significant and welcome collaboration between industry and science, a recognition that the orbital environment is a shared resource that must be managed responsibly. What makes these pearl necklaces so uniquely weird is their transient nature and their symbolism. They are not permanent fixtures. Within a few months, each satellite in the train uses its onboard ion thrusters to gradually raise its orbit, spreading out to its designated slot in a higher, more stable orbital shell. The beautiful, concentrated necklace slowly unravels, its pearls scattering across the globe to form an invisible network that beams the internet to the most remote corners of the Earth. In this, they represent a pivotal moment in human history. We are no longer just visitors to space. We are actively industrializing it. The pearl necklace is the birth cry of a new orbital infrastructure, a sign that the space above our heads is becoming a place of commerce and utility on a massive scale. It forces us to confront a difficult question: what is the true value of an unspoiled night sky? And what are we willing to sacrifice for global connectivity and technological progress? This temporary string of lights is more than a curiosity. It is a portent, a glimpse into a future where the heavens are permanently woven with the threads of our ambition. And now we reach the final and perhaps most profound entry on our list, an object that is not merely a piece of drifting debris or a curious natural formation, but a deliberate, hopeful message sealed in a cosmic bottle. hurtling through the silent blackness of interstellar space, billions of miles from the sun that gave them power. The Voyager 1 and 2 spacecraft carry with them the most ambitious and weirdly beautiful artifacts ever created by humanity, the Golden Records. These are not simple data storage devices. They are time capsules intended to tell the story of our world to any intelligence that might one day find them, long after our civilization has turned to dust. They represent a breathtaking act of optimism, a whisper of who we were, cast into the cosmic ocean with no guarantee it will ever be heard. The contents of these 12-inch gold-plated copper discs were carefully curated by a committee led by the visionary astronomer Carl Sagan. Their task was monumental: to create a portrait of Earth that could be understood by a completely alien consciousness. The record is an analog phonograph record, complete with a cartridge and a needle, and its cover contains symbolic instructions on how to play it, using the most fundamental language we know, science. Diagrams depict the hyperfine transition of neutral hydrogen, the most common element in the universe, to establish units of time and distance. A map, pulsars, the lighthouses of the galaxy, points back to our solar system's location. It is a message built from the ground up, assuming no shared culture, biology, or senses beyond a capacity for reason and curiosity. What awaits any being that successfully decodes these instructions is a stunning sensory journey across our planet. The record contains 115 analog encoded photographs, depicting everything from mathematical diagrams to human anatomy, scenes of everyday life across diverse cultures, and the breathtaking beauty of our natural world, from snowflakes and trees to a sweeping view of the Golden Gate Bridge. But the true soul of the record is found in its sounds. There is a 90-minute playlist of Earth's greatest music, a selection as daring as it is diverse. It includes Bach's Brandenburg Concertos, Chuck Berry's Johnny B. Good, Cynic percussion, a Navajo night chant, and a symphony from Beethoven. Alongside this are the sounds of the planet itself, the crash of ocean waves, the rumble of volcanoes, the songs of whales, the chatter of chimpanzees, and the gentle whisper of a mother's kiss against her child's cheek. There are spoken greetings in 55 ancient and modern languages, beginning with Akkadian, spoken in Mesopotamia 6,000 years ago, and ending with Wu, a modern Chinese dialect. The very first words a listener would hear are, "Hello from the children of planet Earth." The profound weirdness of the Golden Records lies in their dual nature. They are simultaneously a snapshot of a specific moment in 20th century human culture and an attempt to communicate universal, timeless concepts. They showcase our science and our art, our intelligence and our emotions, our capacity for both war and profound tenderness. They are a hopeful, almost naive, expression of our best selves, created at a time of Cold War tension here on Earth. We chose to send not threats or declarations of dominance, but greetings and a gift of knowledge. In doing so, the records became a mirror, forcing us to consider what we value most about our own existence. What would we want another civilization to know about us? The answer, it seems, was a celebration of life's diversity, the joy of discovery, and the universal language of beauty. Today, Voyager 1 is the most distant human-made object, having passed the heliopause, the boundary where the sun's influence wanes and the true interstellar medium begins, in 2012. Voyager 2 followed in 2018. Both are now sailing through the void between the stars, their primary missions long complete. Their power sources, decaying plutonium batteries, are fading year by year. One by one, their instruments are being shut down to conserve energy. Within the next decade, they will fall silent forever, becoming nothing more than inert, golden messengers. Their journey is effectively eternal. In 40,000 years, Voyager 1 will drift within 1.6 light-years of a star in the constellation Camelopardalis. In about 296,000 years, Voyager 2 will pass near Sirius, the brightest star in our sky. The probabilities of them ever being found are infinitesimally small, yet they carry our message nonetheless. The Voyager Golden Records are the ultimate culmination of our tour of the weird things in space. They are not accidental junk or a mysterious natural phenomenon. They are a purposeful, philosophical act. They transform two robotic probes from mere instruments of science into something far greater, vessels of culture, dreams, and memory. They are a testament to a species on a small, fragile world that, for a brief moment, looked up at the stars and decided to send a piece of its soul out into the darkness, not knowing if anyone would ever be there to receive it. In their silent, endless voyage, they carry the most beautiful and strange quality of all, hope, and so our journey through the cosmic menagerie comes to a close. We have wandered from the ghostly face of a nebula to the silent tomb of a forgotten satellite, from a car on an eternal road trip to a whisper of a signal that vanished without a trace. The 30 objects we have explored represent an astonishing spectrum of weirdness, a collection that defies simple categorization. They are human-made junk adrift in a sea of natural wonder, scientific anomalies that challenge our deepest theories, and cosmic spectacles that seem to defy logic itself. Each one, in its own peculiar way, tells a story. They are narratives of human ambition, like the Vanguard satellite, still circling 60 years after its mission ended. They are chronicles of human error, like the tool bag that briefly became its own artificial moon, and they are profound testaments to the inherent strangeness of the universe, from the impossible stars circling a black hole to the chilling void of the cosmic cold spot. What unites these disparate fragments is a single, powerful thread: curiosity, whether it is the curiosity that drove us to launch a record of our civilization into the void, or the curiosity that compels us to decode the mysteries of a Martian blueberry. It is the engine of all exploration. These weird things are the physical manifestations of that drive. They are the monuments to our successes and the headstones for our failures. They remind us that our reach into the cosmos is often messy, unpredictable, and filled with surprises. A simple fleck of paint becomes a deadly projectile. A geological formation on Mars becomes a Rorschach test for our desire to find connection. A myth about an alien satellite endures because it speaks to a fundamental hope that we are not alone. Ultimately, this tour of the bizarre is a humbling experience. It reveals a universe that is far less pristine and far more chaotic, creative, and mysterious than we often imagine. The cosmos is not a sterile vacuum dotted with perfect spheres. It is a dynamic, crowded, and wonderfully weird place. It contains forces that move entire clusters of galaxies and delicate artifacts of our own culture, all coexisting in the same infinite expanse. By seeking out and trying to understand these oddities, we learn not only about the universe, but also about ourselves. We see our own ingenuity, our fallibility, and our relentless desire to push beyond the known. And now, we want to hear from you. With 30 strange wonders to choose from, which one captured your imagination the most? Was it the haunting story of the lost cosmonauts, a ghost story from the dawn of the space age? Or was it the tangible mystery of Oumuamua, our first interstellar visitor that refused to be easily explained? Perhaps the silent, enduring presence of Vanguard 1, the oldest artificial satellite, resonated with you, or the sheer audacity of launching a Tesla Roadster into solar orbit. Let us know in the comments below which of these cosmic curiosities you found the most fascinating. If this journey into the shadows of space has sparked your sense of wonder, then you are in the right place. We are dedicated to unraveling the greatest mysteries of the cosmos, from the secrets of black holes to the search for life beyond Earth. Make sure to subscribe to the channel and hit the notification bell so you do not miss our next adventure into the unknown. The universe is filled with countless more wonders waiting to be discovered, and we are just getting started. Thank you for joining us on this tour of the wonderfully weird things floating in space right now.